Hello, folks. Welcome back after a little bit of a hiatus. It's been, I think, 3 months since the last stream. I've had a bunch of various things come up that weren't really planned, and so everything got shifted around. But now I am actually back. At least that is the what I currently believe to be the case, and we'll see how true that holds. I scheduled a Q&A because I figured, it's been a little while since the last one, but B, I have in the past done Q&As on January 1st, so I figured why not do that again, and then we'll do a sort of longer coding stream, I'm hoping in about a month. We'll see exactly when I find a sort of 8-hour slot to sit down and code again, but I haven't lost track of doing those, so we'll get to it soon. This time, just like last time, we are going to use, I'll show you on screen. We're going to use the website we were wondering that I built in order to basically support these kinds of streams. So I've put a link in the video description for where you can go in and ask questions or vote on other people's questions. Please do use it. I will not generally be answering questions from chat. I will be taking them from here instead. And the way that this site works that I recently changed is it rates things by newest question combined with number of votes. So it's sort of a hotness score. So it's basically, you can think of it as like the average number per second of votes that a question gets. It's not quite like that. It's a little bit more weighted. There's a link all the way at the bottom that talks about how this rating works. But this website is also open source. So if you have a better idea for how to make this better, you can go to the GitHub for it. And I'm happy to take PRs and issue requests for how it might be improved in the future. So with that out of the way, I think we're just going to dive straight into the questions. Please keep in mind, if you're watching it live, that you will have a much better time if you vote for questions that other people have asked than if you ask your own, because otherwise you might split the votes between the questions you ask and someone else who asked a similar question, and it'll end up further down the rating. I won't necessarily just do these in sort of number of vote order or in time order. I'll just pick the ones that seem to generally have a lot of votes, and we'll make our way through there. I'm guessing the stream/video, you can check me on this afterwards, is going to be around 3 hours. Well, we'll see when the questions seem to sort of start to slow down. And with that, let's go back to this view, and then let's start with the first question, which it seems like jump to the top, and that could be because someone is cheating. It is easy to cheat on this, but please don't. But I will answer it anyway, which is, what is your stand on the AI stuff? Have you used them? What do you think on them in general? So I think I get this question almost every stream, and I think the answer that I give each time is, I think they're roughly consistent with each other, but it's useful to check in every now and again on it, I think. My take on AI in general is that it is a useful technique. It's a useful tool. It's a useful, dare I call it, algorithm that I think has been overhyped, but that doesn't mean it's not useful, right? So I think there are some problem domains where what we think of as AI, like machine learning more formally, where it is exceptionally well suited for purpose. And I think in particular, where it works really well is when you have either pattern matching or pattern recognition, where you have a lot of data to source those patterns from. So I don't generally think of machine learning as being smart. I think of it as being really good at spotting patterns that people have seen before or replicating patterns that it's seen before. And that could include combining patterns in, let's call them novel ways, but at least combining them in some way that might appear novel. And I think there are a number of maybe surprising areas where this works really well. One of them is code generation. I don't use it a lot for my coding. And there are a couple of reasons for that, but one that I've touched on in the past is that the code I tend to write both now and the code I was writing at AWS and the code I was writing during my PhD was not very standard, for the lack of a better word. Like most of the code, it is unclear if anyone had written quite that code before. That's not the case for a lot of software development. So for a lot of software development, if you're building, I don't know, a website for being the canonical example, but if you're building anything that like interfaces with AWS services, or you're just like, I don't know, interfacing with the Discord API, like things where there's a bunch of code that does something kind of similar, there's a lot more of the pattern that you want to do representative in the data that the machine learning models have already seen. And so they're better at replicating that well. Whereas if I asked it to, I don't know, implement partially stateful incremental view materialization, even if I did it function by function, I think it would struggle because there's not really anything else for it to base it on. There's no pattern it can repeat. There's not even really a combination of patterns it can repeat. It's not to say it could never be good at it. It's just I haven't found it particularly compelling for that. I think autocomplete is potentially another place it could work well, although I suspect that the algorithmic heuristics work quite well, and it's unclear how much it really adds beyond snippets maybe where it could work well. It obviously works well for text generation, but again, it depends on the nature of the text. Like, for example, if you're trying to take text you've already written and try to turn it into nicer text, like better structured text, then it can use the pattern of nice structure with the content that you have and work pretty well. If you ask it to write it from scratch, less clear. So overall, I think machine learning has some really good applications, but I do not think that it is a thing to rely on for everything, because I think the moment you move away from well-established patterns, it doesn't work very well at all. But where you can find those patterns, it works extremely well. I'll take follow-ups in chat if someone sort of thinks of something that's a sub-question to what I say. But other than that, I'll sort of move through the questions from the site. Okay, next one I see. When was the last time you had to do an algorithmic coding interview, like LeetCode? If yes, did you do it in Rust? Was not a yes or no question, because it says when was the last time, but I'll answer it anyway. So the last time I had to do a live coding question in an interview context was at when I applied to work at Amazon. And it was a bizarre one. Like, it was a phone screen interview. And I was asked to implement Quicksort. And for some reason, I was told I couldn't use Rust because their like interview tool couldn't handle Rust at the time, which was kind of silly because I was being interviewed for owning the Rust build infrastructure at Amazon. So clearly Rust is the thing I should be evaluated on. And it's just, I wasn't allowed that option. So I ended up writing it in Python, which was really weird. I mean, I ended up getting the job, but it was real strange. And it felt really useless, right? Like, I have actually implemented Quick Search on stream, but like, I've never had to implement it otherwise, and it's not really a useful skill to know it by heart. But yes, I have done LeetCode type coding for interviews, and I think it's a terrible idea. I recently had an interesting conversation actually with someone who claimed, a relatively senior person, who claimed that most engineers, like most good software engineers, could easily implement like a depth first search or a binary tree. And my contention was, no, that's not true. That I think for most software engineers, if you pick like 20 years experience software engineer at, I don't know, some random software company, but that is really good at what they do. I think if you ask them to implement a binary tree, they could describe a binary tree, but implement the logic for it, I think they would actually take them a bunch of time and they would make mistakes. Same for like depth first search versus breadth first search. It's not a thing that you've thought about since you studied computer science, even if you even did, or since the last time you studied LeetCoding. I don't think it's actually a good proxy for like a simple programming problem that requires that you know programming, which is often what it's used for. It just doesn't work that way. So yes, there's a long way to say, yes, I've done them. No, I think they're a terrible idea. my experience was not that I got to write it in Rust, but that did seem like a kind of special case. So after I joined Amazon, one of the things that I pushed for was to get Rust support in the tool, which I think they now have, luckily. But it was really silly. Okay. I'm struggling to finish a project, and usually it takes time to kick off when I context switch between job stack and my learning stack. How can I actually finish my projects? So it's really tough, actually, this one. Like, one of the things that I've found is that I keep accumulating more and more projects, whether that be at work or in my personal time, whether those be learning projects or building projects, or honestly, non-computer related projects. They just keep piling on. Like, I started using Obsidian for taking notes quite some time ago, and I started having a sheet of like things I want to do, like one page of like a sort of, not, it's a to-do list, but not a short-term to-do list, but like a long-term want to-do list. And very quickly it has spiraled into, I now have multiple different pages of different categories of things that I want to do. And it just never ends. Like, I think realistically, you'll never find the time. That's not really how it works. Instead, what has to happen is that you have to pick the one that you think is most important to get over the line, and then you have to make time for that one. You're just not gonna, there's no sort of magic wand you can wave and be like, oh, I suddenly now have time for my projects. I do think that the reduction of time for context switching does buy you a lot. It does really help. So if you manage to sort of keep multiple projects at least sort of buffered in your head, then switching between those, you can do a lot faster, and then you don't waste quite as much time being like, what did I do last? And there are two ways to accomplish that. One of them is to have fewer projects that you multiplex between. If you try to multiplex between like 5 things, they're not all going to fit in your working memory, and therefore context switching is going to be expensive. The second one is to reduce the time between when you switch to them, right? So if you have like 3 projects in your brain, 2 of them you switch between work and home, for example, but one of them you only pick up like once every 2 months, that thing will take way longer to bring back into working memory. So the recency matters here. It is actually better, I think, at least in terms of context switching, to work on it like an hour every 2 days than it is to work on it for like 2 full days every other month, right? I don't know if those add up to the same number of hours, but even if they did, like, I think the keeping it fresh in your working memory does make a decent amount of difference here. Let's see. People are asking a lot of new questions rather than scrolling down and voting on questions. What is your opinion about Nix and NixOS? Okay, so this one, I actually have a slightly more, I think, well-informed answer than I had the last time this question was asked. Because I've been using Nix now a bunch more at work, because we use it for a lot of like repeatable builds, the kind of things you would expect to use Nix for. I haven't used NixOS yet. I think the next time I reinstall my laptop, I will try it. I'm not convinced yet that I will like it, but I will at least try it. I think my experience with Nix so far has been that I see what they're going for. I think I see the value, especially for building things like sort of deployments. So when you want to build, you want repeatable builds, like reproducible builds. You want to be able to just quickly build them on whatever host for whatever host. In the sense that like it builds on my laptop, so it's also going to build on yours, and either of us can build the thing that's going to ship to like a staging environment or something like that. Or you want CI to build exactly the same thing that I built locally in order to build it for prod, that kind of stuff. For that, I think it works pretty well, like ensuring you have these relatively sandboxed and reproducible builds. However, and this is something I found at Amazon too, and working on the build tooling there, it forces you into describing your builds in a very constrained way, and one that has a lot of deep, dark corners and archaic knowledge and non-standard languages and poor debug tooling, poor introspection. And it might be that there's something fundamental here, right? Like some of it is you're trying to force every possible build into some kind of structured framework so that you can manage them. But as a result, they all end up feeling a little bit awkward. And I think Nix leans into that by also having a fairly strange language, having somewhat immature tooling, having fairly poor debuggability and introspectability errors. It's just not a very pleasant tool to work with. It can be extremely useful, but I don't think it's a good tool. And I think that is a really painful downside. Like I really wish that if we were first going to do builds well, like we're first going to double down and say like, this is how we're going to do all builds. I would love for that to then have been built with a bit more care to the ergonomics, like to the developer experience. So that's not to say that Nix is a poorly written tool. Like the build parts of it are really good, but rather that the experience of being a user of it is pretty bad. And that I think is sad. It's not, so someone in chat said good concept, not as good execution. And I think the execution is actually really good, but only on the sort of internals and not on the externals. And I think the externals are really important because the people you need to keep all of the stuff up to date, especially over time, those people need to understand what's going on. And I think the barrier to becoming someone who understands what's going on is very high right now. And the ability to learn it yourself is also really bad. And I think that is a very unfortunate combination. It might still be better than any alternative that we have. So it might still be sort of the best of the choices you have, but it still makes me sad. How do you view the Zig programming language? Have you tried it? If not, what are your thoughts on it from an advanced Rust engineer perspective? So I've still not tried Zig. I get this question also every stream. So good to check in case I suddenly try it. And I think my reasoning here has also stayed fairly the same, which is I think Zig is a really interesting language for writing what we think of as Rust unsafe code. Right? It's really good for writing effectively safer C, or safer C++ maybe, but certainly safer C. I think what Zig doesn't quite have going for it is, obviously the ecosystem. It's a much smaller ecosystem, much smaller language. And B, one of the things that's really advantageous with Rust is that when you don't have to use unsafe, two things. When you don't have to use unsafe, you do end up in a safer language. And B, when you do have to use unsafe, you don't have to learn a different language. And I think those two together are really powerful. I think there's probably an argument that Zig is better than unsafe Rust. But Zig is not better than safe Rust plus unsafe Rust. And that, I think, matters a lot more. The cost of having someone learn two languages in order to maintain a project sanely is too high. And I think you see this in like take the Python ecosystem, for example. If you want to write a Python module that includes like native extensions, now you need to be really knowledgeable in both Python and C, and people aren't really. Maybe also, someone pointed out in chat here too, that Zig, it's unclear if it's a safer C or just a better C. I think it is safer than C because the bar for safety in C is very low. But even so, I think the added benefits from safe Rust, I think, are hugely valuable, like in a way that's hard to quantify. And I think, yes, when you do have to drop to unsafe Rust, it is a much more painful experience than Zig might be. But the fact that it's still, I'm going to claim the same language, not just the same syntax, but it's mostly the same language, I think that's very powerful. Will you be doing any more of the CodeCrafters streams? I don't know. I feel like, so I think I've done 3 of them now, 3.5, because one I did part 1 and part 2. I do really enjoy doing them. I do them more because I think I think people learn a bunch from them more so than me learning a bunch from them. I learned something about the tools we're building and whatnot, of course, but they're not really, they're not as much of a teaching thing for me, and they're not as useful to me in the sense that, if I build, like when we ported FlameGraph, for example, to Rust, that was useful to me. Like the result was the FlameGraph tool, but in Rust. It was more maintainable, better tested. I felt like I had a more understanding of what it did. I don't get the same from implementing the CodeCrafters things, except for understanding the thing we built a little bit better, like understanding the BitTorrent protocol, maybe. So that is nice, but it's not really for me. It is, however, and this is the reason why I've done so many of them, I've gotten really good feedback on it being hugely useful to the people watching, that it is a really good way to learn because you can go through the exercises with me, and sort of play it and then pause it when I'm about to start an exercise, do it yourself, and then play the video and see how I did it compared to yours, and then move forward from there. And I see that a lot. So hard to say. It might be that I do another CodeCrafters. It might be that I find some other programming challenge and do that. But I think realistically what's probably going to happen is that I will do more of the sort of longer implementation streams again, because they give me more. And I do also think that they are educational in a different way than the CodeCrafter ones are. And this sort of relates to the next one, like, will you live stream another project building video, like building Redis from scratch? Yes. I don't know exactly what I will build next, but I do think that it's pretty likely that whether it'll be my next video or something after that, I will do a sort of longer, let's implement something from scratch again. And I have a couple of ideas for what that might be, but I haven't fully settled on exactly what yet. Okay, let's scroll down a little to some questions that were asked a while ago, but got a bunch of votes. Let's go down to here. Do you use a debugger like GDB? How do you design Rust code? So this seems like cheating. This is 2 questions in one, but I'll try anyway. Do you use a debugger like GDB? Very rarely. I tend to use it if I get like an actual seg fault, which does sometimes happen, right? Like, especially if you're running unsafe code, you're calling out to a C or C++ library or something, then I do end up pulling out GDB, or LLDB for that matter. And then it's really useful. I've found it much less useful for debugging Rust code. And people sometimes say, oh, it's just because it's not as well integrated into your editor, and then you can set breakpoints and run it and whatnot. And that's true, but I just, the print debug run the test again loop works pretty well for me. Like, I haven't really found myself bottlenecked by that. So very rarely I'll pull out a debugger to like walk through a test that isn't passing, but it's quite rare. It could also be that part of the reason for that for me is because I tend to debug more like multi-threaded programs where the bugs might be more in concurrency than they are in like the straight code computing something wrong. Doing that with GDB is a bit more of a pain. It's still doable. It's just a bit more of a pain. You can use tools like RR to make it a little nicer, but I find that like having really good traces of your execution instead, that you can just easily toggle on and off, and then sprinkling some prints in addition gets me plenty far. I do think that ensuring that you have sort of relatively well traced code from the beginning is one of the reasons I can get away with that. Yeah, and there are UIs for NeoVim that allow you to do GDB style debugging directly from NeoVim, but even so, that it's just not really a need I found that I have. But again, it could be because I do a lot of a lot of trace debugging. So actually, a decent amount of what I end up doing is just logging the traces to disk and then do post processing on the log files or post-processing could mean, grep said whatever awk, or it could be me literally reading through the file, like reordering some lines when there's threading and then diffing two runs and seeing how they differ. That tends to get me there pretty fast. How do you design Rust code, which is the second half of that question? I'm just going to skip because it's too big and I already answered the first half of this one. Decrust rayon. It's not really a question, is it? So what I will say on this one is rayon is a really good suggestion for something to decrust. I get a bunch of good suggestions for things to decrust. The bottleneck for me in decrusting things is more about the extent to which I have thorough, not just experience with, but also knowledge of that library. So I've used rayon. I don't know that I would say I'm a particularly advanced user of rayon, and I haven't really looked at the code very much. And so as a result, if I started decrusting it, I could probably read up on it and get, in a place where I could do a stream, I don't know, without it being, completely learning it from scratch. But I don't know if I'm the best suited person to do a decrusting of rayon, at least not right now. If it gets to the point where I've suddenly used it a bunch for some project that I maintain, then sure. But as it stands right now, rayon is lower on my list. And also, someone else can do it. It doesn't have to be me. If you've used rayon a lot, you feel like you really understand how it works, do decrusting of it. Can you tell us more about ReadySet? Are you still involved? And will you start a new venture in the future? So for those who don't know, ReadySet is a company that I founded along with two of my lab mates from MIT just as I graduated. So in, end of 2020? Time is a flat circle. And it was basically a sort of trying to productionize the research database that I built for my PhD thesis. I have a video where I give basically my thesis defense and describe it. I'll link it up here for those watching this video after the fact. And that company has, spent a few years now trying to figure out what is the right way to turn this into a product, right? Like what is not so much how does the tech work, but rather like what is the thing that you're selling, right? What is not just what do you price and like what do you charge for, but what is the pitch? Like when you go to a company, you'd say, hey, come use ReadySet because like, what is the walk-up experience? And I think now they've gotten to something pretty good that I'm quite excited about. And they recently landed support for, so they have support now for both MySQL and Postgres relatively transparently. So basically you can take your existing application generally suited for like read heavy web applications, not read only, but read heavy. And you take your application and you just, instead of pointing it at Postgres or MySQL or Proxy SQL, you just point it at the ReadySet instance instead, and you point the ReadySet instance at your actual database. And then your queries are like 20 to 1,000x faster. That's the walk-up experience, roughly. There are a bunch of caveats to this. You specifically only want to target some queries where the memory is most well served to optimize your workload. But it is really cool that they now have that experience working for a couple of customers. And I think there's more to come there. So I am still involved. I chat to the team and to the CEO, once a month, maybe a little more often. Depends on whether there's something where I can sort of technically contribute in some way. And that's sort of the extent to which I'm involved. So it's not like I have, it's not like I'm now working for the company full time or anything like that. But that's my current level of involvement, and I expect it will stay that way. I think they have a pretty solid team now, and they're doing good work. So I'm mostly sort of doing what I can to help them there. Whether I'll start a new venture of my own in the future, I don't really know. It would depend on whether I have an idea that I think is sufficiently worthwhile to be that. I have thought about starting a sort of on the side consulting thing, whether that be, bring me in and I'll run Rust training for you, or whether that is more along the lines of, call John for a pull request review kind of thing, or whether that is, hey, we need crate X. Can we ask John to build it for us? I don't really know what that would look like. I don't know if it's something that I would want to, I don't know how big of a thing I would want it to be. I don't know whether I would want it to include other people or just me. This would be something along the lines of what Tim McNamara is doing with Accelerant. I don't really know. I don't have any plans for a sort of company, like in the sense of not a consultancy on my part, but like a company I start. But I'll let you know if that ever changes. I think most of us look to you for inspiration. Oh God, I hope not. But is there anybody who's been your inspiration or someone who's been instrumental in your programming journey? This one's tough. And the reason it's tough is because I don't know that I would say that I have a sort of role model within or outside of tech. But what I have had is up through my life, really, not just my career, but my life, there have been people who have sort of inspired me in various ways or been role models on particular things or have encouraged particular traits in me or behaviors. And I think the sort of string of those people is what I think has gotten me to where I am today. But none of them as like a single individual or something. And many of them are not, what's the word? Like public figures at all, right? Is like, well, one of them, for example, is my high school math teacher, who was, in a way, the person who really got me excited in science, right? He was the one who took the time, like after math class, he was like, for those of you who want to understand why this is the derivative of this, let me show you the mathematical proof after class if you want to. Like he was that kind of person. He was very much into the, let's explore the why and the how, and not just the rote memorization of things. And so he really made me be interested in what's behind the scenes and going digging and understanding the underlying things. My English teacher from like middle school, who sort of instilled, I think, a lot of work ethic in me and also did a lot to get my English to where it is today. And sort of more recent people too, like at Amazon, for example, there were a couple of principal engineers that I worked really closely with and really appreciated the advice of, not just on sort of specific technical bits, but more generally like career-wise or how to think about engineering more broadly. I talk a lot now at Helsing, for example, with the VP of engineering, who I think has some really good thoughts on how to manage people, how to think about sort of a company as an organism almost, and like the internal processes of work, how they work together, how to build it up in such a way that it builds people up and gets everyone to sort of execute together. So in terms of the question, like, yes, there are a lot of people who have been my inspiration up through the way, or that have been instrumental to my journey, but I don't know that there are people that I could like name and it would have any meaning. I could give you these people's names, but that's not particularly relevant, really. Yeah, I think that's the best way I can try to at least answer that question. what do you think about Amazon's recent, very blatant return to office mandates? Well, okay, so this one I think I have already publicly stated feelings about, because this is one of the reasons I left Amazon, was not the most recent announcements, but the sort of precursors to it, which is, I think, Amazon was sort of trapped in between a rock and a hard place. So I think Amazon actually was a company that did a lot of things right, or AWS, I should say, like in terms of their engineering org. They had a lot of good people and a lot of good thoughts on how a company could run well. Whether it was executed well, we could talk about that. I think like the Amazon leadership principles, for example, I think can be pretty good if applied correctly, but the if applied correctly is a pretty big if. The problem was that, and you can see this in Amazon growing extremely fast as a company, like it did a lot of things very well. AWS being a good example of this. But what happened during COVID was that they had to hire a lot of people remotely. This is my thesis, of course. I can't claim that this is true, but this was sort of my observation and reflection, right? They hired a bunch of people that had to be remote because everyone was working from home. And Amazon's culture was not built for working from home. I think there was a pretty big reliance, not necessarily on synchronous communication, but on like people being around leadership and leadership being around employees, in the sense that in the olden days, right? If you were working on, I don't know, one of the software engineering teams, chances are your manager, but also your skip level manager and their manager, you were all like working roughly on the same floor in the same vicinity of each other. So if you were like complaining about something not working or about some process or whatever, chances are you might actually end up in a conversation with someone who could do something about it. And I think that is one of the ways in which information flowed, is that people were around each other, could hear these conversations and could act on them. And there was sort of a ear close to the ground kind of situation that went quite far up, I think. But with work from home, this completely fell apart, right? Because no one was in the office anymore. And Amazon didn't really have a trained muscle for how to do things, not really asynchronously, but do things remotely. And yet they kept adding people who were working from home, who were remote, who were never really incorporated into Amazon's culture and way of doing things. And the effort to do so wasn't really there, in part because they didn't know how it should work. And so I think Amazon found itself struggling over the course of the pandemic that, and again, I'm talking about the software engineering aspect here, or the software engineering sort of sub-org. And I think what happened was there was sort of increasing dysfunction internally, where like leadership felt more disconnected from the work, the failures, the achievements, the goals, the outcomes, the things that mattered, the struggles on the ground, so to speak. And that was felt, I think, in both ends. And then they did the wrong things to make up for it because they didn't really understand, because they weren't closely enough connected. And so I think Amazon hit this point where there was maybe a realization that something's got to change. Like, we don't know how to work this way. And so our options are either try to fix it in the current broken environment, or move back to something we know works and then try to recover from there. And I think this is a strategy, at least I've heard some rumors of this, that this was actually something that was signaled quite early on, but then nothing happened. Like, no one took any steps. And so that's why ultimately ended up being a sort of pretty broad mandate of people will return to office. Like, very few exceptions. You need sign-ons from very high up, increasingly high up as time went on, more days, like really just saying, we're going to do this, people. We're going to all come back to the thing that we know how to do. And of course, I think there was a recognition that this would come at a big cost. I don't think they quite realized how big that cost was. But I think they kind of had no choice, right? Like, I think if they continued on the path they were on, Amazon would not have learned these skills in the already existing kind of broken environment, I think. And so they had to sort of do a reset, but the reset is very costly. And And so that's, I think, how they ended up. And then you need to double down all the way until you get to what you think is stable ground, and you can regrow from there. Whether they will ever reach stable ground now, I don't know. Like, I actually think this is a very painful experience or hard-hitting, I think, thing for Amazon as a company overall. Certainly for AWS. How do you navigate large code bases and start your work effectively? So this one's hard to give general guidance on. But I think what I tend to do is sort of start pulling at a thread. Usually I start somewhere that looks like an entry point, whether that be, it sort of depends what I'm trying to do with it as well. But let's say, okay, here's maybe an example. So somewhat recently, there was a C++ code base I had to port to Rust. And it was written by a contractor of some kind, and the whole thing had to be rewritten. And it had some Python bindings. It was used from Python in a couple places. It was binding to this giant C++ code base. So it had a fairly complicated API, like a third-party thing. It had a bunch of kind of weird tests. It had a couple of command line utilities. And there was sort of a lot of like complexity to it. And internally, the code had a lot of like, let's call it mathematical complexity to it as well. And so this is sort of the question of where to begin. And the place I ended up starting was, I'm going to first read the whole code base. This is not always achievable. Like there is definitely there's sort of a threshold where above a certain number of lines of code, you just can't do that. But if your goal is to port a thing, you might as well just read the whole thing. You're not going to understand everything. You're not going to retain everything, but at least you'll have a bunch of symbols in your head, right? Like I'm talking equivalent to debug symbols where as you're porting things later, you'll like remember, oh, I saw this symbol over here. I remember reading something about this. You'll read and start to get a sort of mental picture of which components are where, roughly what do they do, how the code is organized and so on. And so just reading it top to bottom and then try to make sure you actually mostly understand the stuff you're reading. Like when I say read the code, I mean read every line, and I should understand why every line is there. Not necessarily like understand that the math is right? Like if there's like a, I don't know, formula for computing, I don't know, water displacement. I'm just going to take as good fish, which is a Norwegian expression. I know it doesn't exist in English, but it should because it's a great expression. I'm not going to just assume that, I'm just going to assume that that's correct and fine. That's not important right now. But when I read code like, I don't know, there's like a variable stored on the heap somewhere that keeps a vector of some cached stuff. I'm going to assume that there's a reason for that cache, and I'm going to try to understand that as I read through. Like every line, I want to understand why it's there and not somewhere else and what it's trying to do. With C++, that can be challenging, but I think it's actually a worthwhile exercise. And then after I'd read the whole thing on the sort of medium depth level, then I picked an entry point. And that entry point, I think, was one of the command line utilities because it just had one run command, and it was for running like a sample thing, like some sample data input. It just ran it just to see that the thing did something sensible, I guess. I was like, okay, I'm going to make that thing work. And so then I started porting. And so then the sort of deep understanding starts from the entry point of that function, go to definition, read that, and figure out like, what does all of this code do? And then you do a depth first or breadth first, doesn't really matter, but you source it at an entry point, because that way there's a bunch of stuff you don't end up having to learn right now. And that can be really useful. But I think you do need that entry point. Like depending on the size of the code base, an entry point is either fairly convenient or vital, right? If you have a super large code base without an entry point, there is no way to navigate that code base, and you're not going to read it top to bottom. So I think that's the best I can give for navigating a large code base. You could say something about like reading the documentation stuff, and that can be useful. Reading the tests can be useful. But I think really the two bits for me is if you can read the whole thing, like if you actually genuinely need to understand this code base and work on it on a regular basis, read the whole thing. And second, find an entry point that's useful to you, and then full explore from there. And in terms of starting your work effectively, I don't know how to answer that question, right? Like, how do you start your work effectively? The closest thing I can give to advice here is that it is useful to have a resumption point. So if you stop working on something, like start your work implies that I stopped it at some point, right? Or I guess that would be restart or resume. But I think there's an implication here. The work is an ongoing thing. And I generally find that if I need to resume work later, I want to leave it at a point where there's sort of a hook where I know the place to start, because I know like there's a line that says, to do, continue here. That can be a sort of good motivator for where was I? Oh, I was at this line. Okay, I'll continue from there. If I'm starting a project entirely from scratch, then I think that's a different kind of question. Okay. Mark is answered. How should I go about learning to write and profile performant code in Rust? So writing and profiling performant code are synonyms, is the first thing I would say. You can't write performant code. You can only write performant code by profiling code, finding what is slow, making that stuff faster. You can write code that is likely to be performant, but in doing so, you're going to make a bunch of choices that might, for example, make your code more difficult to reason about. It might make it more complex, harder to test, more error prone, more unwieldy, less ergonomic. So in general, you don't want to default to writing performant code because there's no such thing. What really matters is that you write code that you understand really well, that you have good representative workloads for the thing you care about the performance of, and then that you profile the execution of your current implementation against representative workloads. And then you look at what the hotspots are. And so really, writing performant code comes down to how good are you at profiling code. And getting good at profiling code is just practice. There's a little bit of tooling, like you should know how to run Valgrinds, like cache grind tool. You should probably know how to use perf and flame graph. If you really want to go down into it, you can use like BPF for some of this stuff. A lot of Brendan Gregg's writings on his blog is a good intro to how to do profiling. It's not Rust specific, but it's useful. And sometimes it's even just writing actual benchmarks, right? Like both micro and macro benchmarks. Criterion is useful for this, but there's a bunch of other tools here too that like Tango, if you want to really performance check low-level code. There's also one called IAI, which measures instruction count instead of execution time. But all of this is just like measuring tools. Like really, you need some way to measure the performance of your code, ideally on a function-to-function, line-to-line kind of basis. And you can do that with like print lines if you really need it. And then find where your code is spending your time and then work on making those things better. And as a result of doing that, you will make your code more performant because you'll see where it's slow. It'll tell you. But then over time, as you observe this more and more, you will start to build up some patterns that you know are expensive. Or at least you'll get some sort of intuitive trade-off for, I know that there are 2 ways or 3 ways to do this thing. And this one is slower but easier. This one is faster but way more complicated. Do I think I'm going to need the fast version in this particular project for this particular, code location? And if the answer is yes, then you take that path. But it really is sort of the wrong way around to think of it as writing performant code in the first place. And yeah, all the profiling tools you have for C and C++ and stuff work just fine for Rust. So in general, like if you just search for like profiling native code, you'll get quite far. Let's see. Can we ever truly be free from libc? Yes. So it depends on what you mean by we and ever, right? So as a particular person, you can, right? You can just start using muscle instead. You could start using what's the Rust reimplementation? It eludes me now. But there are replacement libcs that you could choose to use. If you're talking about like glibc specifically, if you're talking about a libc, I mean, you need something that manages your syscalls for you. That could be a Rust crate that directly invokes syscalls. That's fine too. Libc isn't special in that way. So you as an individual can be free from libc. And also ever, right? Like, do you mean get rid of it from all of the software on your computer? Probably difficult. Do you mean get rid of it from a particular software stack? Not that hard, or kind of hard. Depends on exactly what you're doing. But rustc, yeah, that's the one I'm thinking of. But in general, I don't know that being free from libc is really a meaningful goal. I think it's useful to have other competing implementations, if you will. I think it would be nice to have a Rust version of it that you don't need to bind to, for example, and rustc is basically trying to do that. But I don't know if it's something where, as a general thing, we, as in the computer science community, is going to get away from. But maybe specifically in the Rust community, we might be able to replace that with a crate that re-implements them more purely. The thing you lose, right, is portability, in the sense that we would need rustc or whatever ends up being that thing to itself implement a lot of the abstraction or it's not even abstraction really, but sort of the mitigations of supporting multiple platforms so that you can use one interface regardless of which of the lots of flavors of Unix there is under you. Let's see here. I really like your way of speaking. I think it's very careful / precise / I don't know. But I've actively tried to emulate it when I'm explaining things to others. Is this something you intentionally cultivated in any way? And Happy New Year. Happy New Year. I don't know that it is something that I specifically cultivated, like not with intent. I think it's more of a observing that it works in an educational context. I do think I actually do it outside of education too. And sometimes that's good and sometimes that's feels weird. Not because I do it to like impose that on people, but rather because it's so second nature to me now that I just use it elsewhere as well. But it's not something that I specifically cultivated or even really think about doing anymore. It's more, I think, reinforced over lots and lots of interactions that one of the best ways to get my point across is to be very deliberate about what words I use, what order I choose to explain things in. To take a slight sort of detour here, I do a bunch of board games, do as in play, but also I ran a board game group, board game night at MIT for many, many years while I was there. And one of the other places where I've done education is in trying to teach people how board games work. Not in the sense of like how they work on a deep level, but just like explaining the rules. And you have to be almost more patient and deliberate when explaining board game rules to people, because if you're not, they'll get bored, they'll miss things, they'll jump ahead, they'll get confused, they'll get mad, they don't want to play, whatever it is. And so I think I've gotten to hone that skill in a bunch of parts of my life. I'm also, I work at a summer camp for kids every summer in Norway for many, many, many years. And there too, you have to do a bunch of explaining to kids why they can or can't do something, or like what activities are available today. And they're all the same. Like all of these settings, you need to use the same, or you don't need to, but you come a lot further with a sort of mindful approach to how you explain and how you talk. That doesn't mean that it's the right one, and it can sometimes come across maybe as patronizing. That's never the intent, but it can come across that way. It's like, oh, stop being so patient with me. Just fucking say the thing, right? But I do think a sort of side note here is that one of the parts, so I think there are two sub skills here that I have thought a lot about. One of them is I try really hard to only say things that are true. And that might sound like a triviality, but it's actually not. It is surprisingly hard to mostly say things that are true, because it means that you don't get to use generalizations quite as much. Like I tend to be, or aim to be, technically correct as much as I can. Like use accurate language to say the thing I meant to say, and not some other things that might have been sort of taken by implication. And the way I hold myself to it is to say that I try to mostly say things that are true, because otherwise it's very easy to get people confused. It's very easy to confuse yourself. It's very easy to imply things that you weren't implying. It's very easy to get the other person to think they understood something when they really did not. And using more specific language to be sort of accurate in what you said tends to actually clear up some of those confusions more. And the second thing is to know when to leave things out. This I see a lot in board game explanations, for example, that let's take the board game Hanabi. So Hanabi is a card game. It's a cooperative card game where you're kind of playing cooperative solitaire, but you can't see your own cards. You can see everyone else's. So everyone is holding their hand of cards, but they're facing away from themselves. And on your turn, you can take one of three actions. One of them is you can throw away a card. One of them is you can play a card from your hand. And remember, you don't know what the cards are. And third, you can give a clue to another player. And the clue that you can give is you point to all of the cards in their hand of a certain color or number, and you say what that color or number is. So this is how I explain the rules of Hanabi. And notice it's very rehearsed, but it's also very specific. But there are a bunch of things I don't say there. Like, for example, when you throw away a card, you get a clue back. If you play a card and it's not playable, then you lose a life. Those things are important to the rules of the game, but they're not important for that particular flow of the explanation. They can come afterwards. And knowing which things to skip in each part of the explanation is super useful. And when you explain the rules around someone who also knows the rules but hasn't thought this much about it, they tend to try to be helpful and jump in and say, oh, and also, and I kind of want to be like, no, I'm intentionally not mentioning that because it's a more useful way to explain. So those two things I think are very useful techniques in aiding in sort of educational communication. It is try to only say things that are actually true, mostly, and know what to leave out and when. So I'll leave those as the two pieces of advice there. Oh, explaining Blown to the Clock Tower to 15 people is trivial. I have no problem doing that. Do you have any favorite Rust blogs or of programming in general? Yes. Although I tend to not follow... I have a bunch of like random one-off articles that I really like. And it's not so much that I necessarily follow the author and think everything they write is really good. Let me pull up here my Readwise and see what I have. So a couple of examples. For technical writing, I really like Dan Liu. Writes, I don't even know how to describe what Dan writes, but it's just, he writes about sort of software engineering adjacent things, but also patterns he's seen in software engineering, testing and benchmarking, but also sort of statistics and also people management. It's very good. I generally like almost everything Dan writes. Evan Miller, let me put these. So Dan Liu is danluu.com, danluu.com. Evan Miller, so that's evanmiller.org, writes a bunch of interesting stuff about statistics. I particularly like, he has a bunch of articles about how to sort things when you have votes or user ratings of them. That's actually one of the formula that inspired the current ranking algorithm on We Were Wondering. And those I think are really good. I haven't really read much of the other things that he's written. I'm sure those might be good too, but I can't really speak to them because, again, I want to read the specific things, not necessarily the author more broadly. Codahale, I don't know what their actual name is, but it's codahale.com. So Codahale has in particular an article called Work is Work that I think is really good, that I recently found out about. It's very good. And I've heard that they have some other really good articles, but I haven't gotten into them yet. I really like basically anything Matclad writes. I've read, I think, almost all of those blog posts. Let's see, what else do I have that I like subscribe to? I really like sort of for more Rust technical writing. I like Without Boats a lot. I think they're very well reasoned through and thought-provoking in their own way, but also willing to like explore paths, but with a rigor that I think is hugely valuable and inspiring. And I think I learn something almost every time I read one. And then I also really like Filippo Valsorda's blog. Let me see if I can find... So Filippo, so that's words.filippo.io, who maintains a sort of newsletter called Cryptography Dispatches, where they talk about maintaining the cryptography part of the Go standard library. Learned a lot about cryptography from there. I found that really interesting. A lot of Burnt Sushi's stuff that he writes, including like very long Reddit posts, I think are really good. But yeah, it's sort of all over the place. So I don't have like a particular sort of like, yeah, these people you must follow. But these are some of the examples that I think I've come up with more articles from than I otherwise normally do from one person. I worked as a backend developer using Node.js. I wanted to learn Rust because of my desire to learn systems programming. I'm reading your book. There are amazing details. It seems easier to understand, but when I watch your videos, I don't understand it well, and after a while, I lose the context of understanding. I really need your advice so I can learn Rust at a very good level. Okay, so this is trying to take a shortcut. Rust is a language that I would argue is harder than Node.js. And when I say harder, what I mean is there are more things you need to learn in order to really be productive in it than there are in Node.js. It's not like the programming is harder. It's just, it has more concepts in it. It requires more of you as a programmer. I think those are worthwhile skills to learn. And I think when you learn them, they are also applicable to Node.js. But you don't have to learn them in Node.js, whereas in Rust, you have to learn them. I think when you watch my especially longer implementation videos, one of the things you'll find is that the reason it's easy to maybe lose context or feel like you fall off is because those are not meant for people who are beginner to intermediate. They're more for intermediate to advanced. They're for people who already know the language well and want to see people use it for relatively complex pieces of software. If you want to learn Rust as being new to systems programming, you can use my streams to do that, but it's going to be more sort of learning by osmosis, right? Like you'll just sort of absorb information as you go, but not everything will make sense to you, and that's okay. But I think at the level you're at right now, my book is not the right one. And my videos are maybe useful as sort of supplemental material, but it's not the main way to learn. If you're newer to Rust, the places I would start learning is like either the Rust book or the Programming Rust book from O'Reilly. They're both really good. Maybe Tim McNamara's Rust in Action, which is more focused on sort of building something that is more real. Like you're building like a thing. It's guided by exercises. My book is very much not. Maybe a YouTube channel more along the line of like Let's Get Rusty, where you sort of get exposed to more well-defined ideas that are more sort of building blocky or not building blocky, but sort of self-contained concepts rather than being sort of tossed in the deep end. And then do something like Rustlings, do something like Exorcism or CodeCrafters or something like that, where you have a sort of nicer slope to work your way up. My videos in my book are not that. They are not intended to be that. I'm very happy that you're learning from them, but I don't think that's the place to start. I think that's the place to pick up after you already feel like you can program decently in Rust. And I do think, as someone pointed out in chat, I do think that we could use more. I already know programming. I just want to become proficient in Rust resources, maybe. I think we do have some really good ones. Like I think people underestimate the value of Rustlings for this, or underestimate the value of something like CodeCrafters. I think those are the ways that you get good at this stuff the most rapidly, is by just working with the language. It could be that there's some like classes that could work really well here. I know there was a question about this, so we might get to it later, but I have thought about whether there's a resource of some kind that I might build here. I don't know yet. I don't know exactly what is missing or what I would contribute to it, because I think my specialty is more on the experienced end of the scale for education. Should Rust-c move away from C++ written LLVM and leverage a Rust native compiler backend? This is a non-goal for me. I'd be happy if there was something else underpinning Rust, but I don't think it matters that we have a C++ dependency under us. Like this is a stand on the shoulders of giants kind of thing, right? Like use the best tool for the job. It doesn't really matter what it's built in. Like you could rewrite all of LLVM to Rust, but I don't think that should be a goal. And LLVM has a lot of nice benefits. So I don't think we should just go, it's written in a different language, let's throw it away. That is the wrong attitude here, I think. I think it is useful as an exercise to understand the kind of things Rust requires from underneath us. I think it's also useful as what are things that LLVM could enable that it doesn't today, specifically because of the kind of computational model Rust has on top of it that we might see better if we have a very targeted thing built under it. But I think it's, I don't think it should be an explicit goal to get rid of everything C++ underneath. There is an interesting argument around bootstrapping, right? About sort of chain of trust, that you shouldn't need a C compiler in order to verify your Rust compiler, in order to build and have confidence you've built a correct Rust compiler. And for that, it can be useful, right? So you use something like a Rust code generator backend to build your stage 1 compiler, or use that as your stage 0 to build your stage 1, whichever way you want to describe it, and then use that to build Rust itself so that you ensure you get all the optimizations. But I'm not sold on it being important to move away from LLVM, especially if the argument is it's written in C++, that's the only reason. But even if there's a more fundamental reason, like LLVM is not well suited to Rust computational model, I think LLVM has proven that it is flexible enough that it can adapt to that over time. And I think we would do ourselves a disservice to try to throw it away. Yeah, and like if we maintained LLVM ourselves, that would be a lot of work for an already sort of heavily loaded compiler team and Rust team. Like we're talking like another, maybe not order of magnitude, but certainly another giant thing to maintain that currently we can just maintain with other people instead. Someone wrote, but if we replace LLVM, we can make more optimizations from the knowledge of ownership. I don't think that's true. We already do a bunch of that with things like the no alias attribute that gets passed to LLVM. With Mir, you do a bunch of these optimizations. Like these optimizations are already happening, and an LLVM maybe could be better suited to a language that has ownership, but I don't think it's like it cannot make use of that information at all. And I think we're now using I think Rust is now using upstream LLVM. I think maybe there are some patches, but I think most of those have now been upstreamed, but I could be wrong. I don't remember. What are your thoughts on the current state of IPv6 adoption? So, okay. I was told growing up that we were running out of IPv4 addresses. And that's like, I don't know now, 20 years ago. And all I see everywhere is still IPv4. Most networks are not configured for IPv6. Whenever I try to enable IPv6, the shit inevitably breaks, like routing breaks. Suddenly I don't have connectivity. Some websites don't work. Like I don't quite understand how shit's still so broken with IPv6. I don't get it. It was supposed to be this silver bullet that yes, it was going to be painful to adopt, but then everything was just going to work so much better. And it just doesn't seem that like that is true. I do feel like I now see IPv6 pop up in more places. But that's like over the course of the past 10 years has been a gradual slope. It doesn't feel like we're anywhere near the sort of, oh, you can turn off IPv4 now. I don't think we're anywhere close to that. I'd be shocked if that was the case in the next 10 years. Yeah, every year they tell us that IPv4 will die, and I think it's far, far off. Let's see. Scrolling back through here. Yeah, this sorting is too unstable, or you're all asking too many good questions. Are you interested in formal verification and correctness proofs at all beyond the Rust type system? If so, have you tried any Rust specific tools? So I do think that formalisms beyond just the Rust type system are really nice. Some of my lab mates at MIT actually were working a lot with formal proof assistants. They were working with Coq and Daphne and F star, and what's it called? Idris, Iris, something like that. And so, we would read papers in like group reading sessions and talk about those techniques a bunch, and they would show me some of their work and I would read some of their papers. And I think it's fascinating. I think it's extremely promising. I think it is the right direction for computer science to move in order to actually be a science. That said, I think we're very far off it being practical for, I don't want to say real things, because we have already seen impressive papers where it's used for real things, especially for things like verifying the correctness of distributed systems algorithms, for example. What's called the Iron Fleet paper, I think, was really cool on this front. And I mean, one of my lab mates, for example, wrote a paper on a formally proven crash-safe concurrent file system implementation. And that's really cool that you could do that. And it had performance that was quite good. And it was provably crash safe. Like, it didn't lose your files when it rebooted and all that stuff. And it was formally verified. Great stuff. Extremely hard to write. Like, not so much writing the implementation, although that too, because you need to choose a language that either can get code generated from your proof assistant or that can somehow be validated by a proof assistant, both of which are pretty painful. But second, writing the proofs is really hard. At least the sense I got was that there is so much work in writing the proof assistant is an assistant in writing the proof. And then when you have all the things written out that it can check, then it can tell you, yes, this matches. But like, there's a lot of work in between to actually explain the rationale for why something is correct. And then the third thing that makes it hard is that writing the specifications is also really tricky. Like, what does correct even mean? Like, formal verification is checking that the implementation matches the spec. That's really what it's doing. So implementation is hard. Writing the proof, the things that the proof assistant needs is hard. Like, what are the axioms, for example? But third, writing what the spec even is really hard. And you might think of something like the POSIX standard. That's a spec. But one of the things they found when working on this this verified file system was that they were trying to sort of show that they were matching the POSIX specs guarantees for file system calls around crash safety. But of course, if you read the POSIX spec, it's not really a spec at all. It just talks about what should happen or may happen or could happen. And that's not enough to write a proof. So you end up coming up with a spec that you kind of make up to formalize what correctness means. But if you make a mistake in the way you write the spec, then now all your proofs might work out, but you're proving the wrong property. So it's a very hairy, messy field right now that is hugely important, but also sadly very tricky to prove anything but trivial property of. It's possible, but it requires an enormous amount of effort and work and understanding. And it's also understanding that is, I don't want to say disjoint, but certainly highly non-overlapping with standard software engineering. Like, if you take a very experienced programmer and then you told them, try to write a proof for this thing, the amount of knowledge and experience they would need would just be like, they would be able to leverage very little of what they had from before. And I think all taken together, that means that the distance from where we are now until people can use this reliably to build complex pieces of software, I think is pretty far. That said, I think there are ways in which tools can help us here. They can sort of make things better on a shorter timescale. So this is where you use formal methods for proving things about subcomponents of your program. So that could be a particular implementation of an algorithm that you want to show is like exhaustively correct, or you use it to verify the correctness of your distributed system algorithm on a sort of an abstract level. This would be something like TLA plus, for example. The former would be something like Connie. You could do like model checking of your data model or your algorithm. You could use something like IO automata, which has a formalism, like it has a checker that I now don't remember what's called. But you can use IO automata to model sort of systems of components that talk to each other and try to ensure they end up in some reasonable states over time. There's a bunch of tools you can use for subsets of these problems that are easier to model in completeness in isolation. And definitely do use those tools if they are applicable for your use case. But the sort of formal verification for everything, I think we're sadly still pretty far from. Yeah, it was Idris. What do you feel about Rust having no spec? Do you feel that it's any way hindering its adoption in more safety critical industries? So the spec and then the spec and then the spec. So the kind of spec I'm talking about here is like a formalized spec that is understandable by a proof assistant. Rust not having that kind of spec is fine. It's not clear what language you would write it in, not clear what properties you would enumerate or even could enumerate in a meaningful sense. That I think we're pretty far from. And then the spec in the sense of like a, 2,000 page document that you have to pay to get shipped to you as a giant tome, and like cost a bunch of money to get the official one and it's managed by a committee. This is like C++ type thing. That is like tries to be as exhaustive as it can about the behavior of everything. And in some sense, I think this is what, why am I blanking on the name? Ferrous Systems is doing with their Ferrocene Rust. Is basically trying to give you a specified and certified Rust compiler. Like part of the certification, I think, is specification. And that I think is useful if it's required from you. I think it goes a little bit beyond that. I think that's too harsh. It's not just that certification is only useful in order to have certification. I do think it maybe gives you some more confidence in things like someone else has looked at all of the code that went into the compiler. Like it's not just the original person who wrote it and the person who reviewed the PR. Like someone else has also taken a look at it and has sort of vetted, not necessarily the people, but at least the code that went in. Someone has thought carefully about all of the APIs and whatnot. I think there is some value in that, but I think that value is a little overhyped. Not by Ferrous Systems, for example, but like by the industry as a whole. I think a spec is less valuable than it's made out to be. And then there's the third sense of spec, which is like a reference, which Rust does have. Rust does have the Rust reference. And it's not really very formal, but it does talk about like the grammar of the language and the constructs and like roughly how things work together. It doesn't talk about, say, how the borrow checker is implemented, but it does talk about a little bit about the model. And this is where we have a bunch of working groups that are trying to formalize those better with things like stack-based borrows and tree-based borrows. And I think all of that work is worthwhile, but I think what it ends up with is a reference more so than what you would think of as a spec. And I think that's okay. I would like to have that. Like, for example, when writing Rust for stations, a lot of what I had to do is figure out what does Rust do here, and sometimes go to the Rust reference and realize it's not written there either, and then have to piece it together from elsewhere or just from behavior seen in the program. And that is unfortunate. I've not heard of Versus Rust verification, but that's cool. I mean, I do like having more options for verification. I think the only people that care about that would be the government. This is about having specs. I don't think it's just governments. Like you see this in, well, maybe transitively it ends up always being governments, but like the car, like the auto industry, the airline industry, the health industry, those three in particular are very focused on like things need to be certified. And I think part of this for me is it comes down to, I don't know that a certified compiler should give you all that much confidence that the end product is good, right? it feels backwards to me. It feels like you need to prove that the end product is good. And then I don't really care whether your compiler is certified, right? But they do care about certification. Like, you can't get the contract if you're not certified. And that feels weird to me. And maybe it is because ultimately it comes as a sort of government requirement, but then I think the government required is also sort of misaligned with the things that actually are important. Yeah, someone also made the point here that a standard is different from a spec. And I think that's also true. Okay. Let's see. There's some questions from much longer ago that have ended up quite far down because you're asking so many new good questions. Down here, there are a bunch that have from like 5 days ago that have a bunch of votes. Let's do those. Right, let me drink some more water first. Oh, really? You can feel it in like your nose and throat when talking this much. Maybe I should just shut up and just let chat talk. If you could study computer science again, what would you do differently? I honestly, I don't think I would do anything differently. I think I'm quite happy with the journey I ended up taking. So for my bachelor's, I didn't really take any computer science before my bachelor's. Like I did a bunch of stuff sort of on my own on the side, but not as part of actual education. Well, yeah, that's mostly true. For my bachelor's, I actually ended up taking a double major in general computer science. And what I mean by that is you were supposed to pick one major and then take like most of your classes, your computer science classes from that major. Like it could be system administration or security or algorithms or whatever it was. And I just didn't do that. I just picked classes that I thought were interesting, and none of them added up to a major. So I ended up with a double major in general computer science. And that meant that I took everything from like a programming languages class where we learned so many different languages. And then I also took a computer security class. I took like several algorithms classes. I took a game programming class, just all sorts of different things. And I think that was really fun. It allowed me to branch out very early and figure out which things do I like, which things do I not, expose me to things that I could then later on be like, oh, I remember I did a bit of that. So I liked that a lot. And then for my master's, I worked on networked computer systems. And especially I sort of focused on wireless networks for my master's thesis, but the classes were all over the place, just networked computer systems. And that was, I think, a really good foundation to build upon, because so much of what we think about as computer programs today are networked, right? Like there's not a lot of just local software anymore. It does exist, but it's much rarer. And so getting to really dive deep on the network and networking, I think was pretty nice. And then after that, I spent a year working on a research project that was related to like indoor localization, where we were doing like analysis of wireless signals coming into a router antenna array, like just off the shelf, like Wi-Fi router. And then looking at the angle of arrival of those signals to try to localize in 3D space a sender, like the sender of each Wi-Fi packet, by having multiple routers receive the same signal at different times, but at different angles, and then triangulating. And then in order to do that at like line rate and commodity hardware, I had to do a bunch of like hardware stuff and drivers. In order to do it at line rate, I had to do like GPU acceleration for it. So that became more of like a performance oriented and very low level programming type stuff. and that was in C++. And then for my PhD, it was very distributed systems and databases. And so I think that was a nice extension of the networking, but also extension of the sort of performance stuff in the databases are very much about performance, and it's certainly the stuff I was doing. But then also having to think more deeply about the algorithms and sort of domain-specific languages and parsing. And so I think that actually gave me a pretty good frontier, if you will. There are definitely parts of computer science I know way less about, but I'm pretty happy with the place I ended up with and the sort of bulk that ended up behind me there. So I don't think I would really change anything about which aspects of computer science I ended up focusing on. Like I think I'm actually pretty happy about it, which I guess is a nice position to be in. As a software engineering principal engineer, do you manage to properly escape the project management aspects like budgeting, team coordination, schedule, deliverables, deadlines, etc.? If so, it sounds like the dream technical job. So yes and no. As a principal engineer, what a principal engineer means differs enormously from one job to another. And the way that where I've landed on what I think a principal engineer is, or at least what I think my version of a principal engineer is, because I do think there are multiple versions and they can coexist and are all valuable, is that I spend 60% of my time writing code. Maybe ideally a little bit more. In practice, about 60 is my guess. And of the remainder, a bunch of it is like reviewing code, which I count differently as writing code. And I think that's a pretty good balance for me because I really like writing code. However, a bunch of it is also more project management type stuff. Not so much like budgeting or timesheets and that kind of stuff, but more like making sure everyone is working on something that is ultimately useful, making sure the team is sort of collectively pulling in the right direction, making sure that we pick up the right tickets in the right order, making sure that we're not just solving the shallow problems, but we're solving the deeper problems, making sure that we are on the right path to being able to like measure the result of our work. Like for instance, if you come into a project where they don't have any metrics, then depending on the stage of the project, that to me is a huge red flag and something where implementing those metrics and getting like tracking for them, being able to like visually produce them, plot them over time, introspect them is much more important than the next feature you're trying to add, because without that, you don't know whether your thing works. You don't get early warning signs if it gets worse. You end up with your users in many cases being the people who hit the problems and then come back to tell you. That's a terrible position to be in. And these are the kinds of things that like us, like an IC thinks less about, right? Whereas you think more about when you're more, not necessarily project manager, but just like technical lead maybe. And so I do find that I spend a bunch of time thinking about those things, but it's because I think they're extremely important in order to deliver good software. And so it's not as though I am just an IC, because I don't want to be, because I think that what matters to me is delivering sort of impact through software. And some of that, yes, is me just writing a bunch of good software, but a lot of it is also making sure that the whole team around me or the organization around me also do so, and that we build things together, that it comes well together at the end, that it builds the right thing in the right way. So it's like I happily take on some of those more, I guess you could call them project management functions that I think are useful when I think they're useful. There are a bunch of them I don't think are that useful that I try to either make other people do or try to make us stop doing. And so that is another example of something that is not code, but also not project management, which is more like organizational management, right? Like if I see that there's a process that's not really working for the team of software engineers that I work with, I try to change the process, right? I try to also be the person who goes in the room and has that conversation, sort of one level up or one level meta of we're not building in the right way. Not necessarily building the code, but like we're not set up to build successfully. Okay. Oh, an easy one. Do you have any ethical concerns about working on the military industry, while Europe shows a moral decline on major international conflicts? Easy question, see? I mean, obviously, I think I've been pretty clear about this from the beginning. I remember, when I first took the job with Helsing, I held a Q&A, I think a couple of days after I announced that I was joining, but before I'd actually joined the company, where I talked through a lot of these questions on why have you chosen to work for a company like this? Have you thought through this? Have you thought through the ramifications? The very simple answer is yes, obviously I have concerns, but also yes, obviously I've thought deeply about them and sort of still arrived at doing this and have continued to do so for a while now. I think this question is asking something slightly interesting, though, which is, do you have concerns about the sort of, to paraphrase from the question, decline of morality in Europe when it comes to international conflicts? And I think that's a loaded question, but it's loaded in a different way than the asker might have asked, because it depends on who you ask, right? Both whether there's been a major moral decline and where and in which conflicts. Ultimately, though, the logical reasoning that took me to where I am today was one of, I have really strong opinions on how software should and should not be used in war. And I sort of have two options. One of them is, and I'm going to pretext this with, someone is going to work on this, right? There's no world right now that we know of. We don't know how to get to a world where no one has to think about war. There is no war. There's no conflict. Everyone can just do nothing, and everything is fine. We don't have a path to that world. I would love to be in that world, but we're not. Which means that there will be work happening on this, and I have opinion on how that work should happen. And so I could either sort of stand and observe how that work is done from the sidelines, and then yell at people for doing it wrong and suffer the consequences of it being done wrong, or suffer the consequences of poor decisions. Or I can at least try to be in the room and have my voice be part of that conversation, and have my sort of skills contribute to the parts that I think are worthwhile contributing to. And I would much rather do the latter than the former. And so that's why I think it is reasonable to work on something like this. And then the question becomes, is there any company where you don't end up making things worse? And I don't mean worse in marginal ways. I mean like net worse, right? And I did think a bunch about this too. Like there are a bunch of companies in the space that I would not want to work for, because I don't know that I think that they make things net better. And when I first started thinking about working with Helsing, I had similar questions, right? Like, is this a company where I think I would want to be part of the conversations here as opposed to somewhere else, or not at all, right? It could be that there are no companies where I would feel comfortable being part of that conversation, or contributing for that matter. But after spending a lot of time talking to the CTO, the VP of engineering, the founders of the company, and talking through some of the questions that I had and about the sort of concerns that I had, and trying to understand not just how they think about these problems, but also where they might take the company in the future, which I think is an important part of the decision. I found myself convinced that they are sort of aligned in many of the ways that I think about conflict and about the things that we work on and about the space and about how it should and shouldn't evolve. And also that I had confidence that they wouldn't just sort of put it up for the highest bidder, which I think is a legitimate concern when working for a company like this, right? Is that, well, it might be fine now, but in 10 years, who knows where that technology goes? And we'll circle back to that argument later. But I do think that at least with Helsing the way it exists today, I don't see it becoming a sort of up for the highest bidder kind of company. I don't think that the technology that I'm contributing to will end up being a sort of down the line, it'll just be, sold to whoever buys the most shares and they have all the technology and have all the say in where it goes. I don't think that's going to happen. If I did start to think that might happen, then I would leave. I would not be there anymore, but I'm still here. And then the thing we're going to circle back to is this argument that, but like ultimately you can't control where the technology ends up. And that is true, but I think that is true no matter where you work on this kind of technology. So this sort of returns to the argument of someone is going to build wartime technology. And I don't necessarily mean any specific technology. I just mean in general, people are going to build tech for war. And the options that you have when it comes to what you actually build are, or rather to where that technology goes. It's very easy to think that you could just go, we're going to sell this technology and we're going to say it can only be used for defense, for example. But what does that mean? What does it mean to only use something for defense? Again, if you look at Ukraine right now, is it defense to do offense into what was your own territory? It gets really hairy really quickly. Okay, so then maybe you start putting restrictions like it can only be used in this area. Well, what if the enemy advances into an area that is no longer contained in that fence? What do you do? Or what if all the rockets that are being launched at your cities come from outside of that area? What do you do? And crucially, do you really want a company to be the arbiters of who gets to choose? Or would you rather that be the sort of elected government of the related region? Like these, I'm not claiming I have the answers to this, but I think it's a much more subtle question than it might first appear. And even if you could craft the sort of perfect set of these are the things that are and aren't okay to use the technology for, and you tried to put that into the contract for whatever technology you developed, the result is that no one would buy your technology. They just wouldn't. They would be like, well, we're not willing to abide by these restrictions because they are too onerous to follow, or we don't have that level of control, whatever the argument might be. And so the reality is that if you want to have a say on how this technology gets used and what technology gets built, you have to commit to someone as a partner, right? You have to say, we will work with, as Helsing has done, for example, we will work with the UK government, we will work with the German government, we work with the French government, and say, these are governments that we think overall and on a long-term trajectory have generally sound judgment. And again, no one's going to be perfect here, but that's not an option that you have. The alternative is to say, well, we're going to let someone else build it instead, and we're not going to have a say at all. And I think that's worse. And so ultimately, I think you need to choose really carefully who you partner with. And that needs to include how you think they're going to develop in the future. And then second, you need to choose which technology you are and are not willing to build. And that question is difficult too, right? It is really difficult to say this technology we will choose not to build. Or for that matter, this technology we will choose to build. Because the reality is if you're building technology in war, chances are it will kill people if it ends up getting used. The hope, of course, is that it doesn't end up getting used, that the deterrence works, that if you have like invasion stopping technology, you never have to use it because you're never invaded. That is, of course, the hope. But you have to build it as though that might happen because otherwise it doesn't work. That's a bit of a rant, but it is something that it's a topic that's been discussed a lot recently. And I think with this question, it's sort of important to stress that I really have thought very deeply about this. This is not a naively held belief. Okay, let's see. Great. No questions on this topic. Fantastic. I guess this is a follow-up question here. Now that Helsing has released more information about some of the products that they've built, can you provide any more technical details about what you've worked on? Yeah, so far at Helsing, the first bits of what I worked on for quite a substantial amount of my time there was on the lower level or medium to low level network, not abstractions, but network infrastructure. And I don't mean network infrastructure in the sense of like IP networks and the like. I mean it in the sense of the sort of fabric that you use to communicate between different assets on a battlefield. And these deployments are really interesting because you have really weird networks with radios that are very old and that often have extremely low bandwidth. We're talking like bytes per second. Like whether it's like ones, tens, or hundreds, it's like that order of magnitude of bandwidth with very long latencies, very sort of unreliable delivery, right? Like if you have drones, for example, but even if you have assets on the ground or people with radios, they're going to go out of range all the time. Sometimes the radio's not on, it loses battery. You go behind a hill, you go into a cave, whatever it might be. So the networks are very dynamic, very lossy, and very slow. And yet you'd somehow need to build systems on top of that, distributed systems that can exchange information, whether that be, I saw a thing here, or I acknowledge that I see the thing you told me about, or whether that is sending orders, or whether that is just general chatter, whatever it might be. All of this stuff ends up having to be communicated over these networks in a way that works reliably in the face of like really weird network setups. They're often also heterogeneous. Like it's not all radios from one provider, for example. And so I've been working on building the sort of distributed system that sits just on top of that network and then provides sort of a state sharing abstraction to the rest of the systems that sit on top of them. So that was what I did for a majority of my time at Helsing so far. That's been a lot of like interesting work on CRDTs and sort of operational semantics, but also like just general distributed systems, algorithms, logical timestamps, all serialization protocols, all of that stuff, and integrating with weird radios. And then after that, what I moved on to was more sort of simulation-oriented work that I can't specifically go into, but it's more about like flight simulation type stuff, like how to model things flying. And then this was some of the C++ porting work, for example. And then lately, I've been more involved with the Eurofighter project. So Helsing has a contract to supply the radar system for the Eurofighter, or for the next iteration of the Eurofighter, for sort of intent analysis, like understanding out of the things that you see on radar when you're flying a Eurofighter around, which things are tracking you, what are those things, where are they, what are they doing, are they sending something dangerous your way, that kind of stuff. And so now I'm working on those systems instead. So it's a very like varied set of things. And I think they've been both major learning opportunities, but also just really interesting technical challenges. And in some cases, they've given me a chance to be to the previous discussion a little bit, be in really important, I think, conversations around what do you do if you don't hear an order, but you were expecting one? What do you do if you can't send a piece of critical information, but you receive an order that might not work with that? What do you do if you're unsure about the classification of a signal? What do you do if, and all of these what do you do ifs are not, I mean, they are technical decisions. Right? Ultimately, you need to write a code that does one or the other or a third, but they're much more like, I don't even want to say ethical considerations, although some of them are, but they're like human decisions. They're like, what should we do here? What is the right thing? And those conversations are the reason I want to be at a company like this, and like be part of those conversations where I have opinions on what is and is not reasonable. Okay. Thoughts on the Rust 2024 edition? Oh, let's see. Let me pull up the edition guide here to see what actually ended up making it into the edition guide. Rust 2024. What do we have? Oh, I'll share screen here. So this is the Rust edition guide. Rust 2024 has not yet been released. Let's see what we have. Additions to the prelude. Future and into future part of the prelude. Nice. Never need to use that again. This doesn't matter to me. Okay. So future and prelude is nice. Into future might prove nice eventually. Into iterator for box. I don't think I care about that much. Env becoming unsafe, I think, is a bold, cool choice. I wish it wasn't necessary. There's a bunch of historical context here, but very basically, it turns out that setting environment variables is not thread safe. And so the standard libraries setvar and removevar were not unsafe in previous editions to 2024. And so you could just set var for the same variable name from two different threads at the same time. And this is actually, I don't know whether it's technically undefined behavior, but it certainly leads to weird, erroneous behavior. And so in the 2024 edition, the conclusion was they are now unsafe to use. And the unsafety is make sure that there are no concurrent threads modifying the environment list. And obviously, this is going to make a bunch of code now have to be unsafe where it wasn't before, but it's the right call. Like fundamentally, that's what the underlying like libc primitive gives you. So I think that's really neat. This one I'm also really happy about. So this is a new lint, unsafe operation in unsafe function. So previously, if you wrote an unsafe function, the compiler would basically pretend that the entire body of the function was also in an unsafe block. And this, I think, was a mistake because it means that, well, there's a bunch of reasons why that's problematic. But one of them is now you might have a bunch of unsafe calls inside of that function that are safe for different reasons. But because you just get one blanket unsafe at the top, you no longer have to declare each of them with the unsafety block, which is where you would put like a safety comment arguing for why this one in particular is safe. You could still do it, of course, because you can still write, safety comments for each one, but even spotting them is hard. But the second reason is there are some unsafe functions that are unsafe to call, but their body doesn't have any unsafe code in it. But then getting a free unsafe block inside is the recipe for someone eventually accidentally calling an unsafe function without realizing that it's unsafe because they just get to. So in the 2024 edition, this new lint is going to require that even if you're inside of a function that's unsafe to call, you still need to use unsafe blocks for the things inside of it. And this makes me really happy. I think it's more verbose, but it's a step in the right direction. And of course, you can always ignore the lint. If you have a particular file, for example, or module where you do this a lot, just allow the lint in that file. That seems fine. But as a default, I think this is a great change. The capture rules for return position infiltrate. These I gave a talk about this that talks about some of this distinction. I think I gave a Crust of Rust about it as well, maybe. But I certainly gave a talk about it at Rust Copenhagen a while back. I'll link that here for the people watching after the fact. So that one is a really good change. And I think it'll overall just be great. Disallowing references static mute. Yeah, that's a footgun waiting to happen. It's just not going to be allowed anymore. I think it's already a warning in previous edition. It just becomes a hard error. Implicit features going away. I think it also is a good thing. So in previous editions, if you had something like this, for example, in your dependencies list, then previously you would implicitly have a feature called JPEG encoder that if you enabled the optional dependency, and that's now going to go away. Now you're going to have to specifically declare a feature of that kind. Table and key name. Oh, there's just consistency stuff. That's always nice. That's a fix for workspaces. That is a footgun, but it's nice they're fixing it. Ooh. I don't know what that is, but that seems maybe interesting. The gen keyword. Okay, so this reserves gen as a keyword for 2024. It doesn't implement generators, but it makes it so that in the 2024 edition, they could add support for generators using the gen keyword without waiting for the next edition after that. So it gives us hope that in the next, 3 years, we might get actual generators, which would be nice. Macro fragment specifiers. I'm sure that's nice, but I haven't had a need for it. That seems like something similar. Oh, yeah. This one is interesting. So, this is... So this is a fix to make it so that you get fewer compiler errors when you have a type that when you have a function, for example, that returns never. So never is something like a panic. So imagine you have a let foo equals, and you have if something, then call some function, else panic. Then the reason that compiles is because panic returns the never type. Because panic never returns, it will cause your program to abort or unwind. And so therefore it can pretend to be any value for the purposes of type checking, because you know that you never continue executing from there anyway. So it should type check regardless of what you have there. But where that gets weird is, imagine that you had this line, but you didn't have the colon U8. Then there's no well-defined type for panic. Right? Panic itself would say, I can be any type. And then the compiler would error saying, oh, but we can't infer the type of X because panic just returns whatever type. Think of it as like being generic over T and returning T, but not taking T. So the T is never specified here. As the compiler goes, I don't know what type T you wanted here. So the change they're making is that now... it is going, and I think the way they fixed this in previous editions is that if the compiler was about to do that, it would infer the unit type, like the empty tuple, and now it will infer the never type specifically. So when it has a sort of free T that gets returned from something that is never, then it will actually set it to the type never. So if this X didn't have a type annotation, it would get the type ! Which is the never type. I wonder if they say why. Oh yeah, part of this is the reason they couldn't stabilize the never type before now. There's a bunch of details here, so this one I would recommend reading if you're curious about it, but it's a nice change. Unsafe extern blocks. Yeah, so this one, Right. So in Rust 182, you were able to start marking extern blocks with the unsafe keyword, which allowed you to say that. So the reason why extern functions are unsafe is because the function signature might not match the function signature of the thing you're calling. Right? Like that is the primary reason why externs are unsafe. But that meant that you had to like put unsafe on all these functions, even if the function itself is actually safe to call. Like there's no invariance you need to uphold when calling it apart from the signature needs to match. And so unsafe extern allows you to say that like for this whole block, I have checked that all the signatures work out. Like, trust me, the signatures are correct. So that unsafety I've already taken care of. Don't put that on my callers. And so that way inside of here, you can now say this function is safe. Like it is a safe extern function because the unsafety I've checked at the declaration point, and the function inside is now actually fully safe. So this is an extern function that is safe to call. And that is a really nice benefit. And I guess what is going to change for the addition, extern blocks must now be marked with the unsafe keyword. Oh. It is now required to include the unsafe keyword in an extern block. I see. To make it clear that you actually have to check that the signatures match. That's not optional. It's not a thing every caller should do. It's when you declare the block, it is your job right there to check that the definitions match. That's a nice change. I like that. I didn't know about that one. Oh yeah, unsafe attributes. This one's nice. Like no mangle, for example, can actually break your program, can give you undefined behavior. And so there was no way to say that no mangle is actually unsafe, but now there is. That's nice. Rust.combined combined tests. Oh yeah, this is in Rust.doc up until now, if you had doc tests, each individual doc test would be compiled as its own binary and then executed. This was super slow. This is one of the reasons why doc test is slow, because it has to compile multiple binaries that all link against your main binary and then run them. So in the 2024 edition, the default execution mode is that it's actually going to build one binary that has all of the doc tests in it and then just run them. And then you have a way to say, I specifically want this to be compiled as a standalone. And so this is going to speed up building, not necessarily running, but building your doc tests. Nice. I'm excited for the 2024 edition. I'm excited for like every edition. All right. More water. As the business side of a large project evolves and business logic needs to change, you have a mental rule of thumb for when to continue bolting bits on to handle edge cases or just rewrite it. I don't know if I have any good rules of thumb here, except that rewriting it is usually very costly. Your project would need to be either quite small, or you'd have to be willing to invest a lot of resources in the sense of pausing feature development and starting rewrite in order to go with the just rewrite it path. It is vastly underestimated how costly it is. It doesn't mean never do it. It just means that think of it as more costly than you think it is. And then it's more costly than that. The path that I would usually recommend is sort of an in-between of these, is that instead of bolting on bits to handle edge cases or rewriting it, there's sort of an intermediate path, right? Which is every time you add something, try to make the thing that you add fit better. So leave the code in a slightly better state than when you found it. And as you do this over time, your code evolves, morphs, right? Rather than it being a sort of all at once Flag Day kind of change. And I think that's the way better path. The challenge is that it makes every change more costly, right? So the attractive thing of just rewriting it is that you get a bulk of work to just do it. But you forget about the fact that, but we have to pause everything else while doing it, or we have to backfill as we go or afterwards, and the cost of like debugging the thing after the fact. The attractive thing about bolting bits on is that it's pretty easy to add features. The challenge is it gets costlier and costlier and costlier because you're building on top of a tower of hacks. So what you're doing by partially rewriting every time you add a feature is that you are taking longer to implement every feature, probably less than the extreme case of bolting on. Like eventually bolting on will be more expensive than that, but initially it doesn't look like that. But it's more of having the foresight that the extra effort will be worth it later, but you have to be able to convince people that it's worth taking that investment continuously, rather than all at once later, or everything just gets progressively slower over time. Let's see. What are your main media sources to keep up with new technologies and trends? Ooh. Here too, I think I don't have a great authoritative answer. It's sort of a combination of being in many forums. And when I say forums, I don't mean them as in like literal, well, not literal, but digital forums. I mean that as spaces, like social spaces, right? So I get exposed to things through work. I get exposed to things through talking about them on stream, but I also get exposed to a lot of them through the various forms of social media, right? Like on Blue Sky or Mastodon or, Twitter/X, although much less so now. And actually LinkedIn to a small extent. But certainly Blue Sky and Mastodon, I just see a bunch of random stuff there. Whether that's through discovery or just the people I follow and the things that they retweet, which I'm still going to call it. But a lot of it just comes from exposure there. And then, I as I mentioned, like I follow some people who do technical writing and some news sources like that, but relatively little comes through there. I actually, every now and again, I will read This Week in Rust. I don't read it every week, but sometimes I read them in batch. And that tends to be a really good way to just get exposure to a bunch of things that are happening in the Rust project as sort of a burst. And that gives me other threads for things to read and articles. Same with the Rust subreddit. And I'm also in general on Reddit, like subscribed to some like various programming subreddits and the like. And that tends to bubble up some interesting articles. I used Lobsters for a while, much less so now. I don't really know why. I just sort of keeping up with the day-to-day is less important to me somehow. But there's not really one source. It's just sort of things I come across. I do on the on the Discord that I have. So the J Discord. This is the one where I do announcements for streams, but also if you sponsor me on Patreon or GitHub sponsors or I guess YouTube memberships. GitHub sponsors is the main one. But if you sponsor me, you get access to a couple of other channels on that Discord as well. And one of them is one called Nuggets, where I post links to things I think are interesting and are interesting to other people beyond me. And so hopefully some of you end up spotting interesting things from there as well. But really all over. It's very hard to say like, mainly this source. But following the right people on social media, I think, is maybe the most reliable way. And the way you build up that list is actually mostly by like when you see things being retweeted by people that like you see something retweeted that is interesting, go back to the person who wrote the original tweet and then consider following them. Like that is the way I've built up my follower lists over a very long period of time. And that's gotten me to, I think, a pretty good spot. After completing your PhD, do you still keep up to date with academic research in distributed systems and new papers? If so, is there anything you've found really interesting lately? So I had the aspiration to do so when I left. I was planning to be like, oh, I'm at least going to read the sort of main papers, or at least the paper titles from like OSDI and SOSP, which are two of the big distributed systems or systems conferences, every year to like stay abreast of big changes. And I just haven't. I have no excuse. I just haven't. I do, every time I come across an interesting paper, I do. So there's a tool, I guess, website called Zotero, Zotero, that I use for basically logging all of the research papers. So I use it to basically keep track of the papers that I still want to read. And let me see here how many of those I have right now. So in my current listing there, I have 30 papers on my to read list. And these are not ones I've found for specific conferences. These are just ones I've come across, right, from random sources. And so if I also kept up with OSDI and SOSP, then my guess is that list would be about twice as long. And I haven't read any of them in quite some time. So I would just say I don't keep up, but I still want to. Like, I have these papers here because I really want to read them, and I just haven't made it a priority to do so. This gets back to a much earlier question, right? Of like, how do you find time for all of the projects? And the answer is you just don't. You got to pick the thing that like the couple of things that you will make time for, and those are the only ones you'll do. But I have them at least for the one day when I'll have all of the time. In Tim's podcast, this is the Compose podcast. So Tim McNamara recently interviewed me there on like a sort of follow-up to my Eurorust talk, and arguably to my Rust Nation talk before that on like building reliable software. In Tim's podcast, you talked a lot about the human factor in software development, such as communication and its challenges. Are there any resources, aka books or people, etc., that inspired or influenced your way of working with humans? So, as for the question that I answered earlier, right, there's a bunch of smaller inspirations here and there. And a bunch of articles actually here and there. I think maybe the biggest single source, maybe the biggest two sources here are first the summer camp I work at. Like, so I worked at this camp for about 15 years every summer, and it's like, every week, there's about 200 kids and about 30 counselors. And, the first couple of years, you're just kind of, you don't know what you're doing. You're just kind of doing what you get told. But it's like very active. It's like out doing stuff. And you're learning all sorts of things, everything from practical skills to like how to talk to children, to like, arguably like healthcare, right? Like you're just doing lots of things. But then as you progress, you start having to do more and more of like people management. And I don't mean that in the like HR sense, but I mean in the sense of like, you got to like interface with parents. You got to interface not just with individual kids, but groups of kids and groups of kids. You start being responsible for like organizing group activities. You start being responsible for the other employees. Initially you have maybe one or two, then suddenly you're like one of the people leading the camp for that week. And so you have to develop these skills of sort of softer skills, right? Of how do you make sure you know what the other person is saying? How do you make sure that you've actually understood correctly so that you take the right action in response? How do you make sure that your point comes across? How do you make sure that, like, how can you not convince people, but how can you like reconcile when you disagree with someone else in a way that actually moves the whole thing forward? How do you sort of diffuse tension when things inevitably become high tension? How do you handle stress? How do you just manage tasks that people need to get assigned where some of the tasks suck? Like some of them are, someone needs to go stomp the trash container because it's overly full and it hasn't been picked up yet. And we have a bunch more trash to throw in there. Right? Whereas some people are going to be like, your job is going to be on the beach and help the kids who want to go out in a canoe, right? And you're just going to sit there in the sun. That span, you still need to give out tasks for every hour of every day. And I think that sort of repeated exposure to that over time did a lot to build up sort of soft skills. And I think you can get this in a lot of areas. I'm not saying you have to go work at a kids camp, but I do think that being in an environment where soft skills are the main driver for the work, like it's not super hard. Otherwise, it's just lots of soft skills being applied over and over, and sticking with that for a period of time, I think does a lot to help you develop these kinds of skills that sort of pay dividends in all of the other work that you do. And then the second big factor for me, I think, has been during my PhD, I took a minor in psychology. And in particular, I took a class on social psychology that I thought was super fascinating. And so this was about, how do we as humans interact with other humans, be it groups or individuals, right? How do we think of ourselves and act as members of a society in pairs, like in dyads, in relationships, in power dynamics, like just socially? How does it work psychologically? And what are the phenomena? What are the biases that affect us? And that was, I don't know that I would say that it was like revolutionary, because a lot of it made a lot of sense, but it was just being forced to think carefully through it and read some of the studies and getting your eyes opened a little bit. I found that very, very useful. And there was a book in that class that I got a lot out of, and it was called let me see if I can find it. It was by Nicholas Epley, and it was called Mindwise. Mindwise. It's sort of a social psychology book in the sense of like, well, it's like kind of pop science-ish, but it is much more rooted in research studies. Like I found throughout the book that there was lots of references to studies and actually talked through how they worked. And I found that a really good sort of, and digestible to someone who was relatively new to the field. But that I think was a really useful way to sort of get better at understanding other people in a way, and how your interactions with them work. Not in a manipulative sense, but just to better understand how the things you say get received, and how to receive the things that are said to you, and how we act in group settings, and what motivates people for that matter. Have you considered a split keyboard? Yes, I have. I mean, I don't know if I have a split keyboard. So yes, very much so. I would never want to go back. What can we do to help you make more educational YouTube content? This is a question I've thought a lot about, and arguably this is almost more of a question for you, as in the audience, than it is for me, because the big constraint for me in building more educational material is actually there are two things. The first and most obvious one is time. The second and less obvious one is exposure to topics that I haven't already discussed and talked about. All right, so as an example, in Rust for Rustaceans, there isn't a chapter on WebAssembly. I want there to be a chapter on WebAssembly, but I'm not ready to write a chapter on WebAssembly at the level of the other chapters of that book because I haven't used it anywhere near enough myself yet. And so the thing that would enable me to make educational content on WebAssembly would be to do more of it. Now, that correlates with the first one, right, which is time. So it's not just that I need time to make the content itself, but it's also that I need time and opportunity to work with those technologies so that I can then educate with them. And the opportunity bit there being crucial, because imagine I was just dumped a bunch of time. It's not like, for example, imagine I was fired from my job, right? So I suddenly didn't have a job. I would have lots of time. Not clear I could use that time to just like do a bunch of WebAssembly and then make educational content about it. I would probably need to use that time to find another job. So time and opportunity are related here. It's not clear that the solution to time is all time, right? I don't actually think I would want to work to work full time on education, because I think it's vital to have the opportunity to learn, right? The opportunity to be exposed to hard problems in new fields and have to work really deeply on them. And I think the way that you get to do that is in a work setting, right? Where that is the product you're building, or that is the technology that you have to make work at a very high bar of quality. And you don't really have to do that when you're just fiddling with it for yourself. And so that's why I think it's like unlikely I would ever completely leave the work life in order to do education full time. But this is all slight digression. Like in terms of, I feel like in terms of, what can you do to help? There's an obvious correlation between time and money, right? So currently, a lot of my time is bound up in living my life outside of here, right? And work. And living my life outside of here is, I already feel like I'm at the sort of minimal amount of time that I can do that. I wouldn't want to do any less of it. So time can't really come from there. So that would mean time would need to come from work. And I really enjoy the work that I'm doing. Enjoy is maybe the wrong word, but I find it inspiring, impactful, intellectually interesting, important. So I wouldn't want to stop doing what I'm doing. I think it's probably a matter of balance, right? I think that, if we think if I think on the sort of global scale of how can I have the most good impact, whatever that means, I think it's probably something along the lines of a sort of split between the work that I'm currently doing, or at least work that I think is important, and education. And so what that split looks like, whether that's like 3 days a week and 2 days a week, or 4 days a week and 1 day a week, I don't really know. But I think it's probably not 5 days a week, whatever I can squeeze in. That's probably the wrong balance. So I think what I would like to get to is sort of a part-time, being able to take my work down to part-time. And I wouldn't want to do less than part-time because I think it's really important. I want to do this work. But I also think the educational part is really important. And so I would want to step it down, let's say by 1 day to begin with, 1 day a week. But then the challenge would be, how can I, make enough to make up for that 1 day of lost revenue a week? And to be clear, I'm not like struggling financially. That's not the case. But it is the case that working 80% instead of 100%, that is a meaningful change in sort of financial situation. Like I'm currently looking to buy a house, for example, and that is difficult no matter when you do it, really. But it's one of those things where that gets a lot more complicated if you're working part-time and the income source for whatever the remaining 20% is unreliable, for instance, or just generally lower. I think it's doable, but I don't really know what the path looks like to making that feasible. I was hoping the GitHub sponsors might be the way to do that. Let me see. Let me pull up unfortunately, what I've found is that even though I highly appreciate all of the sponsors that I have, the reality is that it's it's about $1,000 a month, which is not nothing, right? It's a meaningful amount of money. It's not money to step down from 100% work to 80% work. It's just not. Same thing goes for the book sales, for example. That is more money, but it's very infrequent and it's very hard to predict. And it's also not enough to step down work. And so I think the way to bridge that, I'm not sure. I think, and I've thought a lot about this, I think there are maybe 3 paths to doing this. The first path would be to do, let's call it sponsored content. But I don't know if that's the right word. So sponsored content would not be of the form, hey, John, we're going to pay you a bunch of money and then show our product to your people and say that you like it. I wouldn't do that kind of stuff, but take CodeCrafters, for example. So for CodeCrafters, they approached me and said, we've built a thing that we think is good and aligns with what you think is important. Would you want to show it on your stream? And I said, first of all, I looked at it and I said, this looks promising. I'm happy to do a stream on it, but I reserve the right to say, this is shit. Don't get it. And they said, that's fine. And then I had a referral link where if people sign up through the referral link, then I get a certain percentage of the money that they end up spending on CodeCrafters. And that worked out really well. Not only because I think people got a lot of value out of the CodeCrafters stuff, and I still think it is a really good way to learn, but also that worked out quite well in terms of sponsorship for me. I definitely did better as a result of those streams than I have from all of GitHub sponsors and Patreon, by far. And so doing that kind of sponsorship where in a way that still aligns with, I only want to promote things that I genuinely believe are good for some value of good, and then finding companies that are willing to make that happen. I don't know how to do it, but I think that is one possible path. And for example, I have the videos about my software and hardware setup. Maybe I could reach out to the companies that make some of that software and hardware and be like, hey, would you want to sponsor me talking about that on a stream? Because I'm already using it anyway. So I'm not changing what I'm telling you all, right? But at the same time, I'm getting something in return for it. But I don't know how to do that. I'm going to abuse the word, but ethically, right? I don't know what the right way to have sponsored content is. I could go the sort of very standard route of just saying, I'm just going to have sponsored segments, at the beginning or middle or end of all of my videos. I'm going to say, and now for a word from our sponsors, right? And then talk for however long about something that someone paid me to say. I could do that. that would probably be fine, but it just feels wrong or not useful. I don't know. The second path is to build a paid educational resource of some kind. I think realistically it would probably be an online course. I think it would probably be a beginner course, although I don't like making paid beginner materials because the people who tend to need the beginner materials are the people who don't really have that much to give in the first place because they are beginners, right? They're more likely to be students, people doing this in the spare time. That doesn't feel right to charge those people. Certainly not enough that it would make a difference. So I would rather make those resources free. I feel much more comfortable charging for Rust for Rustaceans because it is a book for like intermediate to advanced programmers in Rust. And I think in general, they're also going to be in a better position to pay for that. Whereas for a beginner course, that's much less true. So maybe it looks different. Maybe it's a course that companies can pay for their employees to take if they're trying to onboard a bunch of people onto Rust. Similar to like the Google or Microsoft intro classes they've put online already. And maybe that's something where I like sell it in bulk and it's not actually a publicly available thing for individuals, but it's more of a bulk package for companies that individuals can also buy at a discount. I don't really know, but maybe something like that. I also don't know exactly what that class would consist of. I have some ideas actually and I've talked about these on stream before, for like how I would do it differently from how it's being done today. But I don't know. And part of the challenge there too is developing a resource like that, a good online course, is so much work. And that requires time as well. And that time is what I don't have in the first place. So then I've played with ideas like things like doing a Kickstarter for making a Rust online course. And then like, because with the Kickstarter, you get the money up front, then I could use that to reduce how much I work, or just to take a sabbatical, maybe to say, I'm going to take a sabbatical to build this, supported by the money from the Kickstarter to build it and then release it. That could maybe work, but that feels backwards too. So that path, like I've thought about, I don't know how it's going to work. And then the third is to just sort of, I don't want to say come hat in hand, right? Because we're not at that point at all. But like stress even more so that I want to do this and that people should sponsor me more. And then I promise that down the line, as a result, there'll be better Rust educational resources. But that feels like cart before horse, right? It's like, give me a bunch of money so that eventually in some vague way, I promise I will build better educational resources. People are very hesitant to give money in that way. The people who do sponsor me today are doing that, right? Like that is the thing they've signed up for. There are no rewards on my sponsorship at all. You get access to these Discord channels. There's a little bit of value in that maybe, but like realistically, relatively little reward. So they're taking a bet that by supplying me with something, I am able to continue to do more of what I want. And so that is great. But it's very hard to get people to put meaningful amounts of money behind that. Maybe I could get a company to sponsor me in that way, right? So there are companies out there that would benefit a lot from having educational resources. But if I went to Google, for example, and like applied for a stipend from them to build educational resources, it would come with you will have X and X done by Y and Y date. And that wouldn't really be how this would work, or maybe it could, right? But it's unclear how the ordering of the sequence diagram works. And I mean, Helsing, for example, are already in a way sponsoring some of my educational stuff, because sometimes I will do streams on work time, and that is fully acknowledged by Helsing that that's fine and that's something they think is important. Or I'll write articles on work time that are circulated. Like I do get to do some of this. I could ask for more, but in some sense, that feels unfair. And I don't know how to describe it with a word other than unfair, but it is true that Helsing benefits a bunch from this kind of educational content. Totally true. But I think it is weird for them to bear the entire burden. And I think it's like engineers are pretty costly, right? And so to say to an engineer, we're just going to say, you're going to do much less actual work for us and instead go do educational stuff that benefits us eventually. They're doing a little bit of that, but asking them to commit significantly more to that, I'm hesitant to do. It could be that they're totally willing. I haven't asked, but it's because I feel uncomfortable with it somehow. So maybe this is a me problem partially, but I've ranted for a while now. But this too is something I've thought a lot about. I could have a free entry-level course, as someone's saying in chat, and then have a more advanced but paid course. But now I need to develop 2 courses, and that's even more time. Would you be open to get paid to make specific content in some specific subject related to Rust, such as tutorials and such? That could be an interesting path too, although, there's a question of who would pay for that, right? Like, is there a company that would sort of pay me a decent amount of money to make a tutorial for their software? Maybe. Would I want to do that? Would I be good at that? I'm not so sure, right? Is that where my specialty lies, to like read their documentation out loud and then show some code examples? Maybe it is, but like I think lots of people could do that. I don't think that's where my skill is. So this is all to say, like, I don't know what the right path forward is. I do think that the sort of sponsored segments or sponsored videos is probably the most reasonable path here, or most incrementally reasonable path, but I don't know yet. Something like Tidelift or Drip is another one where you get money by people having transitive dependencies in your open source stuff. It is also maybe an avenue, but the challenging part there is that although I maintain a bunch of crates in the Rust ecosystem, they aren't widely used enough that I think it really matters, but I could be wrong about that. I don't think it would add up to anything substantial. Okay, that was a long answer to a short question. Let's see where we at now. Have you read about the academic research around CRDTs? If not, does it interest you in the sense you might make longer implementations videos on them? Oh boy, have I read about CRDTs. Yeah, so a bunch of the work that I've been doing on this state management stuff I've been doing at work is around CRDTs, is using distributed systems research to solve this problem well, rather than come up with just like ad hoc algorithms for sharing state in an unreliable network, which CRDTs are great at. So yes, I've done a lot of work and read a lot of papers on CRDTs over the past year or year and a half. I might do a video on them at some point. It's an interesting topic because much of the complexity doesn't lie in the Rust code, or at least not initially. Like some of the stuff where it gets really complicated is how do you build schemas on top of CRDTs. There you have to do a bunch of Rust and you do code gen and everything, but that is quite far removed from the algorithms themselves. So I would have to think about how interesting it would be to watch and how useful the intermediate artifacts would be. But yes, I've spent a bunch of time thinking about it. What do you think about GUI Rust-side like Dioxys or Tauri? And is it worth to learn? And why Rust trends are less in these things like GUIs, OpenCV, AI like TensorFlow? I don't understand the second half of the question, but the first half is, what do you think about GUI Rust-side like Dioxys and Tauri, and is it worth to learn? I actually have an open tab in my browser, like in my... I have a bunch of places where I have bookmarks, but one of them is the open tabs in my browser. And those are the things that I'm planning to look at the soonest. And one of them is Tauri. That's not an endorsement of Tauri, but it's more of this seems like an interesting thing. It seems like an interesting approach that if it works out, I'm excited about. But I don't know whether it works out yet. It's not been around for long enough for me to say that it's a slam dunk or will stick around forever. I haven't used it myself, so I can't say how well I feel it works. But it is interesting to me. Is it worth to learn? Too early to say. This comes back to a sort of learn for a reason, learn by need. I think there is a not unhealthy obsession, but I think there's a lot of learning that happens motivated by like, I should be learning. So let me look at all the things that people are learning and writing about and just learn about all of them. And I think that's the wrong way to go about learning because you're not as motivated to learn any of the one things. I think instead, you should pick a problem you're trying to solve. Pick like an outcome that you want, whether that's a tool or like an algorithm or a dependency or something, like a web page. Like pick a thing you want, you need to build, and then build that. And in the process of building that thing, you'll have to make a bunch of technical decisions and choices of technology and technology stacks. You will have to learn a bunch about those technologies, but it'll all be motivated by you're trying to build a thing. And so that way you'll have a much better understanding of the trade-offs that you're making because you're actively making them as you build the thing and you see how they pan out. So rather than trying to learn about them in isolation or be like, oh, I've heard lots of people talk about Tauri, I should learn it now. Instead, build a thing. And if it happens to use Tauri, then you go learn Tauri. Or if you think maybe it should use Tauri or could use Tauri, use it and see how it works. But I wouldn't do it the other way around. I wouldn't learn it because it's a big thing. I would learn it if you find that it might be a good fit for a problem you're already solving. Oh, we have someone quoting Bible verses in chat. Why? Okay. All right. I think we're starting to get through the sort of big hitters of the questions. Oh, here's one. 60 votes from 5 days ago. What is missing in Rust? What is missing in Rust? This is a very big question. I think I get this question too in slightly different guises almost every time I do a stream. And it's either what's missing in Rust, what's like the feature that you've seen in another language you want Rust to have, what's the most broken in Rust, what would you change in Rust version 2? And I think every time I give slightly different answers because I'm never quite prepared for this question, even though it comes every time. There are a couple of things that come to mind to me. Some are small and some are bigger. One of the smaller things that I want is I want custom test frameworks. And this sounds like a small thing, but I actually think it's bigger than that, which is I think there's a lot of value in tests, perhaps obviously. But I think in writing tests in Rust, it's very easy to write relatively simple tests. It's possible to write fairly advanced tests. Things like quick check work quite well, sort of a macro that generates a bunch of tests for you. But it's a very limited structure, right? You get to write individual test functions that run in isolation, that run in parallel with each other, some hand waving. and they don't really get to share anything with each other, and that makes me sad. And I feel like I run into this a lot when I start trying to write more integration style tests, more complicated tests, where I find myself wanting the test framework or the test utilities in Rust to have more functionality. Things like setup and teardown, things like shared resources, things like controllable parallelism, things like dynamic ignore rules, things like suites of tests that are related that share setup sort of hierarchically and share teardown hierarchically. Things like parameterized tests. And I know that like utilities exist for a bunch of this stuff, but it all is a little tacked on, right? If you look at something like Insta, it works really well, but it doesn't work well if you have an assertion in a loop, or in a, worse yet, in a function that gets called from multiple places. Or for test enumeration, you have things like RS test, and it works really well, but it ends up with your test just having like case, it's the name of the test _ case _ 0 _ case _ 1. You have things like quick check, and it works really well, except for you have to either pull in sin as a dependency, or you have to use the macro that has a little less expressive power that sort of that's built in with the attributes. And that's okay too, but then you need it's just the keeping all these caveats. One thing I ran into recently, for example, is I have a bunch of tests that I want to run in in the test for We Were Wondering, actually, where I want tests that use like a local database storage for all the questions and votes. And then I want tests that use DynamoDB, whether that be a local DynamoDB or a real one. And the tests that use DynamoDB require that you've either set the AWS environment variables for a real AWS deployment or for the local DynamoDB instance. But in either case, they can only run if those environment variables are set. And so what I really want is I want to be able to say that this test is marked as ignored unless this environment variable is set. That doesn't work. You can only mark tests as being ignored or not, and it's a static property. And all of these things are like, someone could build a crate to make thing A better and thing B better and thing C better. And they are doing that, but they all come with these caveats because they are all constrained to this relatively fixed and simplistic way to model tests. And I know you have harness equal false, right? And that gives you the extreme opposite where you control everything yourself. I want something in between. I want something where I still get the structured output for tests that JSON formatted and stuff. I still want cargo tests to work and to have I don't know. I want better support for more advanced ways to write tests. And the thing to get here is custom test frameworks, which has been an experimental RFC for quite some time. And I really want that. I think it would make a big difference. And I think we're not seeing experimentation as much as we could in the ecosystem because it doesn't exist. And that makes me sad. So that's sort of one of the bigger things I feel like is missing in Rust. I think the other is a sort of meta programming with types. You get some of this with const expressions, but it's not really programming with types. You get some of it with just the trait system, but it's not really programming with types. You get some of it with macros, but then you don't have types. You just have syntax representation. You get some of it at proc macros, and then you can infer the types maybe sometimes, but you don't really have types. You just have the token trees. And I really wish there was a way to have something. I've heard that this is related to or similar to this. What's it called? Comp expressions in Zig. But I want slightly more expressive metaprogramming that's not just syntactical. Yeah, the Zig comp time. I want. And I was so sad that the initiative to do more of this in Rust ended up on the journey, the terrible journey that it did. I thought that was really promising, and now I don't know who's going to pick it back up, if ever. So that I think is something that's missing. And then I think maybe the third is we've gotten pretty good in Rust now about having benchmarking tooling, things like Criterion, Tango, II. It's another one that I'm now forgetting the name of. Well, regardless, there's been a few of them, and we have okay profiling support with like perf and flame graph and with Valgrind working pretty well with cache grind, but I want a little bit more. And this actually applies to C++ and C as well. But I feel like there's another level missing. Like if you look at something like in Java or in Go, if you run the profiler, you get more information. It's because they have a runtime, right? I get that it's easier, but I would love to get better information about like memory profiling, like where are things allocated and where are they going? I want better information about like where is the time going in asynchronous execution, more introspection into the Tokyo runtime. I know Tokyo console exists. It's fantastic. I would love to have more. I want more integrated, better ways to get insights into why my program is behaving the way that it does. And I think those are the first three, at least, that come to mind. I'm sure there are more, but those are the first ones that come to mind for me. And ABI comes up a lot too, right? Like the ability to export a sort of dynamically loadable Rust thing, which also would allow you to do better cached of compiled artifacts for Rust and distributed builds and stuff. That would be nice, but that one's lower on my list. Valuable, but lower. Divan is the other benchmarking thing that I was thinking of. I haven't used it, but some people apparently say it's nice. Okay. Let me scroll through and see if there are any big number vote things. What are you looking forward to the most in 2025? Well, I'm hoping that we're going to end up buying an apartment, and I'm looking forward to having my own place. And I don't mean that in the sense of like not having roommates. Like I don't have roommates apart from my partner. But like having a place where I own the walls and like I can change things and I can replace things, like a place that I'm not paying rent for, but I'm paying a mortgage so that I own it. Like that, I am looking forward to that. But that's sort of more of a life scale, I guess. On the, I guess I can choose how to answer this question, right? Whether I want to take it as a technical question or take it as a personal one. But let me give one of each. So on the personal side, I think buying a place is something I'm really looking forward to. And then on a technical level, I'm going to ignore the Rust 2024 edition. We just talked about it. I really hope, although I don't know if it's going to be the case, but I really hope that next year is the year of either the improved borrow checker or the improved trait resolver or trait solver, because both of them unlock a bunch of long-standing sadness that like is solvable in Rust, but is currently pain that can't really be solved in the current world. And I don't really care which of them I get. I just really want to get at least one of them next year. I don't know if that's feasible. I don't know if they're close enough for that, but I hold a secret hope in my heart that 2025 is the year for that. How are the cats doing? The cats are doing fairly well. They both weigh slightly more than they should. We exercise them a bunch. We play with them like 4 times a day, which is too much. And we like feed them the right amounts, but I think they're just getting older, I guess. Or they just need to exercise more. But they're great. Miso is I think is sort of a truism, or not truism, but I think it's very commonly the case that when you have 2 cats, one of them is a well-behaved princess or prince, I suppose, and the other is some kind of chaotic neutral being. And Miso is very much the chaotic neutral being. We have discovered that she loves what are called cat bongos on the internet. Specifically, she loves to have the top of her butt just in front of her tail patted quite hard repeatedly. And we've had her now for 4 years, and we discovered it this year that, well, I guess 2024, that she just goes nuts for it. And now she demands it multiple times a day. And she only wants it in 2 specific places in the apartment. And that is in the bathroom in front of the toilet, or on her scratching mat in front of the TV. Those are the only 2 places she wants them, but she demands it there all the time and is the best thing in her life. So that's Miso. Just to explain some of the things she's weird about. She also loves to be in the same room as us, especially if we're doing something, but she doesn't want to be too close and she doesn't want to be touched or pet. She just wants to sit there and watch. She's a weirdo. Chai, on the other hand, is very lovely, wants to sit in our lap all the time, even when it's inconvenient. And Miso has a bunch of health problems. None, luckily, very serious, but she just has a bunch of them. Chai, on the other hand, has basically no health problems apart from weighing a little too much, but she is allergic to chicken. And it turns out almost all cat food has chicken in it, and it has been extremely hard to find one without. And so a big part of our journey of 2024 has been trying to find even a single food she can have that is also not terrible for her. So that's how the cats are doing. But they're both sweet. We love them very much, and they're both in good health. Will Miso ever give us some more of your YouTube shorts about Rust things? Maybe so. I still have my list of more of those shorts that I wanted to do, and I just, in the move and everything, it just sort of went out the window, and then I haven't started back up again. But it is maybe that is the thing to pick back up, because they're relatively easy to make, luckily. Okay. Okay, this one's great. Is it okay and still corporate to wish your company, Helsing, will never ever have an opportunity to make use of its products? Yes, I think that's very much okay and still corporate. The dream outcome is that no one ever has to use any of the technology that we build. I would love for that to be the case. That's a good way to frame the question, I suppose. Okay, so now almost all of the remaining questions have fewer than 20 votes, or are things that I've already answered, I think. So here's what we're going to do. We're going to take a break of about 5 minutes, and during those 5 minutes, go through and vote for questions that you would like me to answer in the remaining, let's say, half an hour of this stream. So try to not ask new questions because they will not get enough votes. Instead, go through and vote for the questions that you would like me to answer in the last half an hour here. I'll send you the link again in chat. Oh yeah, cat bongos are fantastic. And so we'll take a 5-minute break, and then I'll be back, and then I'll resume the questions. All right, let's see how we're doing. Okay. We have some new questions surfacing. This is good. All right, let's see here. Out of the ones on the first page, let's do these roughly in number of votes order, and we'll see how far we get. How do you train yourself to choose the right abstractions when coding in Rust? Parentheses traits. I think this is also one of those where the way that you train yourself to do it is by experimenting, right? It is by when you're faced with how to implement a particular thing, like what implementation strategy or design to use. Sometimes go one way, sometimes go the other way, until you build up a sort of reasonable calibration for which of the two ways work well for which kinds of problems, or which kinds of scenarios. I don't think there's an easy way to train yourself in the absence of real world experience. So I think this is very much of a, like, you learn by doing, you learn by building up the, not muscle memory, but the experience or the understanding of the balance that's involved. In general, I feel like people use traits more than they need to in Rust. Very often you can get away with concrete types, like this is sort of a you ain't gonna need it kind of thing, where you try to be generic just to be generic, and it's not clear that the thing benefits a lot from being generic in the first place. And part of this is related to the, I think, aversion that many people have in Rust specifically to dynamic dispatch, where I think we've sort of been very highly affected to use generics everywhere because that's the most performant, that's the most rustic way. And it's a little bit true, but it's nowhere near as true as it's made out to be. And so I would generally say that by avoiding traits a little bit more, you are probably choosing the right abstraction a little bit more often. That's not to say they're never right. Like, they definitely are handy in almost every code base. It's just to use them strategically. And the way that you learn that is by experimenting and thinking carefully about what trade-off you just made. I need to do ordering in my head. 34 is greater than 27. Now that you use macOS at work, would you say that the Rust perf/mem debugging experience is worse than Linux? So yes and no. So on macOS, I have used the, what's it called, instruments tool to do some benchmarking of a Rust program. And I found it pretty useful. I think I still prefer flame graphs, but I didn't mind the information that instruments presented to me. And I still think I managed to like figure out the thing that I needed figuring out. I think there's a lot more tooling built around perf than there is around instruments. And if you sort of go down to the level below instruments, right, which is, I think, dtrace on macOS, you can invoke dtrace directly yourself. And if you look at something like Inferno, which is the Rust port of FlameGraph, it has a stack collapser and therefore also works with FlameGraph for dtrace. So if you capture something using dtrace, you should be able to feed it through the standard FlameGraph tools. But of course, not every tool is going to work fine with dtrace as well. So I don't know that I would say that it's like markedly worse, at least not that I've noticed. I think where it gets trickier is once you start looking at things like eBPF, for example, where you can capture like really low level statistics about the runtime of your program. That is a hugely valuable utility that you have on Linux that is a little harder to replicate on macOS. But not like markedly worse. 27. Oh, I have two that have, 29. That saves me from solving the two equal numbers problem. Do you utilize fountain codes in your current position? No, I'm not using fountain codes in any of the stuff that I'm working on at the moment. They're cool though. If you don't know what they are, look them up. They're cool. Okay. Since you have a background in distributed systems, have you ever used Elixir, Erlang, or any of the Beam-based languages? If so, what did you think? I have used Erlang very briefly, but it was during my bachelor's in that programming languages class that I mentioned. Then we had to use Erlang for like one assignment. So I don't think it really counts as using Erlang. And Elixir I've sort of glanced at but never used. So no, which I do think is interesting, right? Because these are the languages that are sort of, at least on paper, built for distributed systems. I think what I've found is that as I think is often the case, sort of pragmatism comes in the way, where ultimately you need to build real software that does real things in a messy real world. And you're sort of limited to a bunch of constraints around where you're going to deploy, how you're going to run the thing, what kind of performance requirements you have. And so you're not really making the language decision in isolation. If you were, I think there are more places I would use Erlang, for example, where like, oh, I'm building what's a good example of something that's like just a distributed system? And honestly, maybe that's what it comes down to, right? Is that Erlang, I think, is very good at if you're building something that is sort of entirely an actor-based program. I'm using actors loosely here as a term, right? But once you start building things that are slightly more integrated, convoluted beasts, it's a little less clear to me that you would want to use Erlang everywhere. Which is not a really strong motivator for, someone is cheating the votes again. Please stop doing that. It's poor form. I will just hide both questions. So it feels like talking to a school child. But yeah, so I'll sort of say that I haven't been in a situation where I could just pick language completely freely with no other consideration in mind. And I was just building a distributed system where Erlang was a perfect choice. The last time I was in a position where I could just freely choose a language is when I started the research database I'm currently working on, or not currently working on, but that I was working on during my PhD. That was weird. Like my brain reset to that's what I'm currently working on, which is not the case. And that's when I first picked Rust back in like 2015, because I was like, this seems to fit the bill for the kinds of things I will want to build this system for. And that turned out to be a really good decision. And so I think that's I think that was a really good choice. And I haven't really been in the same kind of situation for something where I would choose Erlang since. There's a 37 a little further down and a 52. So 37 and a 52 were. Yeah, I mean, there are a bunch of higher ones that I've already kind of answered. Would you use Rust for a new project in a company where people are excited about Rust but have no experience at all? This is a really good question, just because I think there's sort of a notion going around, and has been for a while, that, oh, Rust is the correct choice, right? That like you should be building your stuff in Rust. And while I think there's a lot of merit to choosing Rust for things, I think that merit is is not universal. Like, you need to think about the other constraints on choosing a language, such as what is everything else written in? Do you have expertise among the people at the company? Would it be easy to get that expertise otherwise, or up-level the people who are currently there? And the reality is that Rust is like a pretty hard language to learn. There's a pretty steep adoption curve for people to bring it on. It's not trivial to hire people for Rust, certainly not at more senior levels. And so if you have a company with like a giant existing tech stack and a bunch of people who don't know Rust, adopting Rust for like a major piece of your infrastructure, saying we're going to rewrite it entirely, is just not feasible, or certainly it's not a good idea. And so I think what you'll generally want to do there is, if you have a very small set of people with experience, your investment in the language should be similar. Either you have to go all out and say, we're going to like hire a bunch of people and teach everyone Rust, which I think is probably a bad idea. Or you have to say, we're going to start with this component, which can be handled by a small number of people. And like, even if they leave, it's not critical that that component is now hard to maintain, right? You need to think about the case where that this doesn't pan out as well. So you need to be really strategic about what is the first piece, what is the second piece, what is the third, what is the cost of them failing, what is the cost of taking the people onto them, what is the cost of rewriting it later on if Rust doesn't work out. And so I think you should be, especially in a place that has a bunch of established software and established people, be very careful about just sort of declaring that Rust is going to be the future now. So be mindful of that decision. What's a programming concept or area that you initially found challenging, and how did you overcome that difficulty? I realize I start almost all my answers with because it's my thinking noise, I suppose. I think one thing that I found challenging early on, and arguably still do, is or maybe not challenging, but I was always uncomfortable. And maybe I'm going to avoid jumping ahead of myself, but one thing that I was always uncomfortable with was automatic memory management. And it's going to sound stupid, but like, I was always bothered by like, where are these values? Because I remember like, I was like thinking about the hardware and like RAM and stuff. And then I think I was writing stuff in PHP. I was writing stuff in Python. And I was like, I don't understand how this actually runs. And that bothered me. And so I actually found it nice to go to a language like C, where I was like, I can hold all the things now. Like, I know where everything is. I manage it. I have control. And so I overcame the difficulty by, I suppose, realizing that there was another way. It's not really answering the question very well, but it was something where like my mental model was really weird. In terms of something that I like found actually challenging, I think one thing that was interesting to me was as part of some of the classes I took at MIT, one of the classes was computer security, and there's a lab on what's known as concolic execution, which is related to but not quite the same as symbolic execution. Where you try an execution of a program and then you try to sort of exhaustively check every path of the program by monitoring the conditions that apply and don't apply, and then use a SAT solver to find values that explore other branches. That hurt my brain for quite some time. And I think the way I overcame it, which is the way I've sort of suggested in a couple of these answers now, is like, I just did it a bunch, right? Like I worked on the lab and I tried to like get all the corner cases right. I worked through it on a whiteboard. I sort of worked it all the way down to making sure that I really didn't just solve the exercise, but understood why it worked in the end.
which is still not like really explaining how I overcame it, but tenacity, I suppose, is maybe the answer, or sort of diligence, or exhaustiveness, or something along those lines. Someone asked for the previous questions. This was the one on choosing to use Rust. Can you expand on the question when it concerns a startup? So I guess this is a new company. You're writing a bunch of new code. Is Rust a good choice if you don't have a lot of people who know Rust? I think if you're a startup, execution speed matters a lot. And execution speed is not something you're going to get out of everyone trying to learn a technology for the first time while you're also trying to prove out an idea. I think when you're trying to prove out an idea in the very beginning, what matters is that you get to something useful. It doesn't matter that you built it in the best way, because chances are the first thing you build, you're going to have to build again. Like in the startup phase where you're just like demonstrating that it works, demonstrating the value. So there, I would rather lean into the expertise that my teammates have in the sort of founding team than I think I would say, we're going to all learn Rust now and build it in that. Unless the exception to this would be if you think that the thing you're building will require Rust, like down the line, there will be no other option. Then I think maybe that advanced investment is worthwhile, but I think that's a high bar. Yeah, I really need to do something about getting a sort of host view almost for these votes. But I think we're back now up to the top here. And then I'm going to subtract the cheated votes. Is the adoption of Rust slowing down according to your view? No, I think it's accelerating, actually. Or actually, maybe it depends on whether you're talking about relative adoption or absolute adoption. I think absolute is accelerating, but I think, relatively speaking, is fairly still. This is pure speculation on my end, but my sense is that, you get a certain percentage uptake of Rust each year, but that ends up being sort of cumulatively a sort of exponential growth in terms of the actual numbers. Or not. No, exponential would be if it's 10% return on what you've already adopted. So it's not exponential, but it is, I think, you're seeing a relatively constant rate of adoption. And as the industry is growing, that also means more and more companies are taking it over. And I think it's beyond that, actually. I think the percentage is also going up now that I think about it. I think what we're seeing is more and more companies being willing to invest in Rust and take the risk on Rust because they see bigger companies succeeding at it. So I think across the board, it's actually accelerating, not slowing down. What new technologies are you willing to learn this year? For example, game development, machine learning, etc. Willing to learn. I'm willing to learn lots of technologies. What technologies will I have time to learn? Unsure. I am learning a bunch of machine learning through work. And so that is a thing that I will learn more about. I think so far, at least, what I've learned a bunch more about is actually more like spatial reasoning, like more things like rigid body transform and math, which is stuff I haven't really done very much of before. But I don't know if that's something that will persist throughout the year or if that's more of a now thing. Game development is up there for me. I do think it's really fun to think about the kind of problems you solve in game development. I think it ends up being like a bunch of interesting intellectual problems to solve in something that is fun. But whether I will have the time, I don't know. Have you considered going vegan? No, I have not considered going vegan. I mean, considered in the sense that I've had the thought and then answered myself no. I think, the the question is a little bit shallow in the sense that it's a yes or no question to something that has a bunch of nuance to it. For example, I eat relatively little red meat. And that's for a number of reasons. It's not just sort of animal well-being. It's also John well-being. So like that's an example of something that's sort of a little bit related, right? But it's not the same. But going full vegan is not something I think is not something that I personally see the value in, at least for me. That's not important to me in a way. Which is not to say it can't be important to some people, but it's not the right thing for me. Same thing with vegetarian, actually, although I understand that one more than I understand vegan. Like vegan, I struggle to understand in a way the motivation for. Vegetarian, I understand way better. But no, I think vegetarian as well would be very hard for me. And I sort of question the utility sounds overly utilitarian, but I question the importance in a way. I think or what I mean by that is more that I question the absolute nature of it. It's not that I think some of the cases aren't severe. It's that I think those cases are the problem rather than the requirement of going all the way to vegetarian. If the concern is things like treatment of animals, for example, if you go all the way to like no animals should die, I'm not there. We're ending with the hard hitters here. Does Helsing sell arms to Israel? Would you stay there if they did? They do not sell arms to Israel. So Helsing currently only sells, or sells is also the wrong word. We do sell, but we're not a sort of shop. You can just come in and pay for things. The way it works instead is that we partner with particular governments of our choosing. So Helsing works with the UK, with Germany, with France. In general, we work with European democracies at the moment, and even the sort of definition of democracy there is pretty narrow. And like a judgment case, it's not a sort of this is the automatic grading rubric. It's not like that. Would I stay there if they did? It's a very hard question. It's a very nuanced question that I don't think I could answer reasonably on stream in a reasonable amount of time. I think the answer to the second part of that question is it really depends on a lot of the details. I would be pretty skeptical, but I'm not prepared to say either way. I think there are far too many nuances and details to answer that question, but I would be skeptical. What do we have? What is something in programming that you think is underrated? Also, what is something outside of tech you think is underrated? Oh, what's something in programming you think is underrated? And what is something outside of tech you think is underrated? In programming, something that's underrated is good comment hygiene. I've promised for like a year now that I'm going to publish a blog post about how I write comments. And I think writing good comments is extremely valuable, but also difficult and requires a lot of discipline. And yeah, I think comments are really underrated. There's a reason why. So in my editor, you'll have seen this on streams. Comments in my code are not syntax highlighted like the dark gray, so they're almost invisible. They're highlighted in bright orange because I think in many cases the comments are more important than the code. I think another thing that's underrated in programming is really good code reviews. So I think there's sort of a generally universal view that code reviews are important and valuable. However, I think that what I view as valuable code review is very different from I looked at the code and it looks fine, hit the green button. So for me, the bar for code reviews is actually pretty high. This is also something I should really write something about. But for me, if I approve a PR, it means I think this is good work now and for the future. Like that is the bar that I hold. And so that's why it will sometimes take quite a long time to get a PR past me. And it can be frustrating. But it's frustrating, I think, in a constructive way. Like I've had a lot of conversations with my teammates about this and about people I've sort of collaborated with, that I don't think I do it in a sort of dragged out, annoying way, but rather I try to make sure that the code that ultimately lands is the best code we could have landed and something that we can live with down the line. Like this is a solid contribution. The bar changes a little bit depending on exactly what you're building and what stage of the system development lifecycle you're in. But in general, I think people hold way too low of a bar for code reviews. And I also think that they nitpick too much. And this combination is really important to that. More comments is not necessarily better, but more thorough code review and a higher bar is important. Nits are not a higher bar. In terms of things outside of tech that are underrated, things outside of tech that are underrated. I was about to say board games, but I don't think they're underrated. That's a very good question. I don't know if I have anything particularly insightful here, like things outside of tech that I think I've like spotted as a genius thing. I think I have one, although it's a little bit of a privileged one, which is time is one of my most valuable resources, as I think it is the case for a lot of people. And like we talked about, like I would love to make more time. I just don't have a good way to get time back, right? And paying to not spend time when you have the opportunity to, I think is underrated. I think if you have the opportunity to pay an extra whatever amount of dollars to save yourself time, it is very often an investment that's worth it. So an example of this might be to have groceries delivered. This is something where, yes, it makes it more expensive, but if you are able to afford that additional expense, then the time it saves you, at least for me, I value that time a lot. And so sort of discovering that there are a bunch of things that you can exchange money for time in the opposite direction is, I think, I don't want to go so far as to call it a life hack because it's not, but it is something that I think is underrated. Like instead of being like, oh, but it's like, I don't want to spend the extra $5 or something to get delivery. Just if it saves me the time, then that's worth a lot to me. Let's see. If we have another. That's a good one. Favorite non-tech thing, which I think most people underrate, is taking a nap. Taking naps is fantastic too. I totally agree. So the reason I was thinking about board games was because, not so much because I think board games are fun. I do think board games are fun. I think it is but it's more that I don't know if they're underrated, but they are underrated in one aspect that maybe is worth highlighting, which is I think they're a really good way to build social bonds with people, be that professionally or not. Like, it can be a bit of a struggle to find games that people who are not really into board games will still enjoy. But if you manage to do that, you get a really low friction way to have, or sort of lubricated way, if you will, to have social interactions that tend to be great for building relationships over time. And I think that part of board games is underrated. Okay. I think we're nearing the end of my stamina here. How about we do as we often do. I'm gonna put my glasses on for this one. We're gonna do a speed run through here. So I'm just gonna read the list once, top to bottom, and answer the ones that seem like I can answer them relatively quickly. And we'll start the speed run here, and we'll take it for about 10 minutes, maybe. We'll see how far I get. What is one thing you regret learning in 2024? Do you think some technology is dying soon? No, I don't think so. And this, I think, is partially because my learning tends to be motivated by things I need to solve a particular problem. So by learning them, they've already been useful. Next. How about GPUI from the Z team? Have not looked at it. What language would you main if Rust wouldn't exist? Go was my one before Rust. I would probably play around with like Zig. Seems like a thing that I would probably play with. That seems close enough to my nature. Erlang maybe. Hard to say. How do you see Rust in the Linux kernel in the near and further into the future? It will be there, and I'm hoping it just takes on more and more. Have you used Ghost TTY? I have not, no. I'm very happy with Alacrity. I'm happy that it doesn't have very many features. Have you made any updates to your setup recently? No. I think it's actually almost the same as the last. I have switched out the lens on the camera. The lens on the camera is now a 28 millimeter lens instead, because so that it can be a little closer to my face. Because otherwise it started catching the top of the screen. Are you neurotypical? I think so, but it's very hard to say. What do you think about the present and future of graphics programming in Rust? I don't think about it very much. I'd love to think more about it. Maybe if I do more game programming this year. Why is your mascot a llama? It's not it's an alpaca. So that answers that question. I've been learning Rust for about a year, and I'm curious, how challenging is it to land a first job working with Rust? My sense from seeing around is that it's surprisingly hard to get Rust jobs as juniors right now. If you're a senior person who knows Rust, it tends to be easier. But that's a very sort of high level sense I have from the market. Decrust Actix Web. This is the same as for Rayon. Can't do it unless I know it really well. Someone else could do it though. Have you ever had to fix memory fragmentation issues for Rust programs and have to use malloc trim? I have not. What are your plans for 2025 around content creation? Can we hope for more streams? see earlier answers about finding and making time, but I hope so. What do you use to keep knowledge, make notes, etc.? I use Obsidian for keeping track of things, but it's more for to-dos than it is for keeping track of knowledge. I don't really write down knowledge, so I tend to forget a bunch about it, but that tends to be okay. It's like a garbage collector in the brain. How do you stay motivated? By working on interesting things. How can you stay so lean all the time? Do you go to the gym or follow a diet? I don't really go to the gym. I don't really follow a diet, but I do eat pretty healthily, I think. I also don't really snack. And I don't really like sweets. And so I think that combination helps. I can't remember the last time I drank soda, for example. So maybe that helps. I also like to walk, so then maybe that helps. Hard for me to say. The luck, probably part of it. What do you enjoy except coding? Meaning when you aren't programming. Dungeons and Dragons and board games in general. Rock climbing when I get a chance. I really like playing squash for a while, but now I haven't done it in ages. I really like writing in general. I haven't written any fiction, but I really like writing. So maybe one day I will. I like mentoring. I like talking about life and trying to give people advice, and certainly seeing when they succeed. Yeah, let's go with those. And I like playing games, like video games too, but I think that all sort of goes in one package. Just going through here. I recently started reading Rust for Stations, but I need to constantly look things up and so on. So is this an intended way to learn using the book, or should I be at a level where I already know all the things you're using? If you're looking a bunch of things up while reading the book, then it is serving its purpose. That's a great way to read it. It gives you a bunch of other things to explore on your own. That means you're learning. Success. You're doing it right. When did you pick up Rust, and when did you think this language is right for me? I picked up Rust in 2015, end of 2015, start of 2016, for the research database, for Noria, for my PhD. And I thought this is the right language for me when, after onboarding 2 more people onto that project, they were both able to not just be productive, but also not really mess anything up or introduce major bugs because of the type system safety. I think that was maybe 2 years later or something. Why didn't you stay in academia? Because my experience was that academia, at least in computer science, tend to be building things for themselves rather than building things for people. And that bothers me. I want to build things that are useful. I want to build things that other people can build and use. And academia tends to be a little too self-focused for that to work out. The incentives aren't quite right for building actually useful things. Okay, we're almost at the end here. Everything's jumping around because people are voting. Oh no. Oh no. The bottom of the feed is a dangerous place to be. I'm learning my lesson about sorting dynamically. Is self-teaching Rust and eventually being good at it possible? I don't have a CS degree either. I think it is possible. I think people are succeeding at it. It just takes time. It is a lot to learn in Rust, but I think you can get productive relatively quickly. Are you afraid of dying too early? No. No, I'm not really afraid of death. I I don't welcome death, to be clear, but I feel like I've made a pretty good use of my life. And so if I die, it would suck, but I would be okay with it. Is the best way I can describe that, which I think is a pretty good position to be in. I think your English pronunciation is nice and easy to listen to. I'm struggling with speaking English, so what was the key to improving your speaking skills? Well, so part of that is just being exposed to a lot of English. Like I basically never watch anything dubbed. I watch it all in English. I read a lot in English. I write a lot in English. I speak a lot in English. So a lot of it is just like exposure and practice. But I think there's a separate component, which is being honest with yourself about what your shortcomings are. So sometimes that can be recording yourself and listening back and listen for the things that don't sound quite right and then work on those specifically. Like it genuinely can be a matter of like, sometimes you just got to like be willing to accept the things you're bad at and then go, I'm going to double down on getting better at those. And sometimes that requires external help. You can't necessarily always do it yourself. What is the tech stack for this? The tech stack for this is Svelte plus Rust plus AWS with Axum and Cargo Lambda. See also the open source repository. LLVM and Zig both support arbitrary sized integers, U1, U2, for example. Do you happen to know why Rust doesn't implement something similar or why it may be a bad idea? I think the reason is because it's not entirely clear how you represent U1 and U2 in the hardware. So you end up with this, like the compiler makes a decision for you about how to pack them. It does that anyway, but now like which operations it uses to manipulate a U1 in a struct with other U1s, like it gets really weird. And I think they just didn't want to have to hide that complexity from the user because Rust doesn't like to hide things like that. That would be my best guess, but it's not a very satisfying answer. You mentioned in a past stream that monomorphization of generics is an impediment to distributing the Rust standard library as a static library. Can you explain more about this? How can C++ distribute a static library even though it has templates? Because in C++ you still distribute the header files, which I think is where the templates live, if I don't remember incorrectly. But I don't know enough about how C++ distributes a standard library to say. There's a really good article on faultlore.com about the Swift ABI. I'll put it in chat. That talks about how Swift did it and why Rust can't do it that way. Okay. I know that you've expressed your aversion towards blockchain. With so many Rust jobs in Bitcoin and your own background in distributed systems, is the reason for that aversion all the scams around that space? The scams certainly don't help. But I think the other reason is because I have yet to see a compelling use for blockchains that are not solved by just having a database. Like I haven't seen something where the trustless nature actually buys you anything meaningful. I think the enormous waste is also a big part of it. I know that doesn't apply as much when you have stake-based chains, for example, but it's just, I'm seeing a lot of downsides and not really an upside is the main reason. And I'm not one to work on something for the sort of purely for the intellectual curiosity. The impact needs to be there for me. Are you still enjoying Norway? Yes. I still think it's a little quiet for my taste. I think I like to be in a bigger, livelier, more diverse city. But it is nice. It's a comfortable existence. And this winter is less cold. Please share your thoughts about this old bug that allows obtaining more than one mutable reference at the same time. Rust critics often use it as an example to argue that the language is not completely safe. this comes up a bunch. So there are a couple of Rust soundness bugs that have been known for a long time. I'll pull it up here. So it's this one. That can be used. So you can use stable Rust code to do unsafe things and break the type system. Totally true. However, the reality is A, these are few and far between. B, they're often very hard to trigger. C, they're often not triggerable without malicious code. And D, you probably shouldn't rely on the safety of the type system in the first place in order to guarantee these properties. That's not what it's for. It's there for catching accidental bugs, not malicious code. Because malicious code can always be malicious in other ways. It doesn't need to subvert the type system for that. So a bunch of those reasons. That's not to say it's not important to fix. It is a high priority thing to fix. It's just that it's very complicated to fix. That's why it hasn't been fixed for a long time. With the exclusive Arch Linux Hyperland setup, how do you deal with documentation? LibreStar, StarOffice is good enough. Never ever. Microsoft Word, LaTeX. Documentation for me lives in like Rust crate docs and markdown book if I need to. I don't want to ever open an Office program in order to write documentation. Okay, I think we got to end there, but I am not quite at the bottom, so I'll run through even faster. Yeah, see, there it is. Single worst part feature of Rust. It gets asked every time. How are you able to keep up with friends from different time zones? And did you make new friends or reconnect with old ones when you moved back? I keep up with them by asynchronously keeping up with them, but also I keep up with them less often. That's the reality of living in different time zones. Did you make new friends or reconnect with old ones when you moved back after so long? Both. Have you tried the Z editor yet? No, I have not. Haven't had a need. Do you find that being back in Norway makes up for any potential career or income upside lost for being in the US? Would you ever consider going back if an incredible opportunity came up? I will never move back to the US. I have no interest. I'm also not from the US, right? Like, so there's no real thing for me to return to. I don't think that the living situation in Norway is, I don't think that the sort of effective, like income is the same because of the benefits or anything. That I don't think it's true. I think you just straight up get paid better in the US. But I would much rather live here than there. Oh boy, this just keeps going. I think we got to stop here. This is a good sign that a Q&A was needed though. All right, and back on the top, do we have anything that deserves a sort of last mention here? Any wisdom on borrow versus asref and when to implement them? The documentation in the standard library these days does do a decently good job, but it's hard. Okay. I think we're going to call it there. There's still like a bajillion questions left. There's no way I could get through all of them. Okay. With that, everyone, let's see. We started at 6:30. Okay, so this is about 4 hours of questions. We got through some hard ones and some easy ones. What chair I use? It's still the Hog Capisco. But thank you all for coming. Thanks for asking all of the many questions. For those who stuck through the whole time, I can't believe you did that, but thank you for being with me. I hope you feel like you learned something or got some answers. Next stream should be a long coding stream. That's at least my plan. And with that, I'm going to go sleep and go to bed. I hope to see you next time. See you all.